Okay, we're good to go.
Okay. So I picked for my topic Agile methodologies, more specifically Scrum, Kanban, and extreme programming. And Alexis, don't come at me because I know that you probably know more about extreme programming than I do. So I'm only going to cover like a little bit of it. I'm not going to go in depth. I'm sure that if anybody has any questions, I might have to be like, yeah, I'll ask for you. Okay, anyways, my dog is coughing. So the core of the Agile methodology was developed by 17 people in 2001 in written form, and it has 4 main values: the individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. So high level, Agile is a process by which a team can manage a project by breaking it up into several stages and involving constant collaboration with stakeholders and continuous improvement and iteration at every stage. The Agile methodology begins with clients describing how the product will be used and what problem it will solve. This clarifies the customer's expectations to the project team, and once the work begins, teams cycle through the process of planning, executing, and evaluating, which might just change the final deliverable to fit the customer's needs better. Continuous collaboration is key both among the team members and with project stakeholders to make fully informed decisions. So here's kind of an umbrella of Agile. There is lightweight approaches and fuller approaches. When I was doing my research, I actually didn't recognize a lot of these on the fuller approaches. But the ones that we're going to focus on the lightweight side is Scrum, Kanban, and extreme programming. And so I did like a little bit of research. So what exactly is a lightweight methodology versus a heavyweight? So lightweight is a software development method that has only a few rules and practices and only ones that are easy to follow, versus the heavyweight, which is a complex method with many rules. That's kind of how the heavyweight works. So the first one I'm going to talk about is Scrum, because that's the one that my team actually uses. So there's basically 3 main roles. There's the product owner or the product manager, the Scrum Master, and then the Scrum team, which is the developers and the QA. And sometimes there's also a QA lead and a dev lead or a dev manager. So the Scrum framework within which people can address complex adaptive problems while productively and creatively delivering products of the highest possible value. So Scrum is lightweight, simple to understand, but difficult to master. And I know this firsthand because this is something that I'm continuing to learn. So a little bit of background for what the roles are. The product owner is the person behind the product idea who watches over the entire Scrum process. The Scrum Master, which is kind of what my position is, ensures the workflow eliminates obstacles and trains the Scrum team. Kind of the go-between between the product owner and the Scrum team, because the product owner usually is covering more of the client stuff and they don't get a whole lot of time to talk to the team. So the Scrum Master is usually the go-between. And then the Scrum team, which is the developers and the QA, they're a self-organizing team that performs all product development processes. So when I say self-organizing, the teams choose how to best accomplish their work rather than being directed by others outside the team. Cross-functional teams have all competencies needed to accomplish the work without depending on others not part of the team. So the team model in Scrum is designed to optimize flexibility, creativity, and productivity. A little bit about how the iterations work. So we have the product owner creating or prioritizing the backlog. In sprint planning, this would be like the first day of the sprint. Sprints usually last between 1 and 2 weeks. For my team, it's about 2 weeks. The very first day of the sprint, we sit down as a team for about 2 hours and discuss what stories or work we're going to be pulling into that iteration. And meanwhile, throughout the iteration, I will be working with, or the Scrum Master will be working with the product manager or the product owner to prioritize the sprint backlog, or the current sprint and the backlog. So every day we have daily stand-ups, which lasts about 15 minutes, where the team talks about what they did yet. We'll go through each team member and they will talk about what they did yesterday and what they're planning on doing that day. And then at the end of the sprint, we will present usually to our CEOs, our VPs, and some of our stakeholders. And then we'll do, so that will be the sprint review. And then we'll also do a retro or sprint retrospective, which would be us looking back at the sprint, spending like about 15 minutes looking back at the sprint and talking about what went well, what didn't go well, and for the next iteration. So prescribed events, usually in Scrum, again, kind of reiterating what I just said, to create regularly and to minimize the need for meetings and not defined in Scrum. All events are time boxed. So when I say time boxed, that means like hours needed to complete. Once a sprint begins, its duration is fixed and cannot be shortened or lengthened. So when we bring on a certain amount of work, it either gets finished in that iteration or rolls over to the next iteration. The remaining events may end whenever the purpose of the event is achieved, ensuring an appropriate amount of time is spent without allowing waste in the process. So just kind of going over again the events that I was talking about: sprint planning, sprint backlog and refinement, daily Scrum or daily stand-up, sprint review, and retrospective. So next one I'm going to talk about is Kanban. One of my another person in the Plano office that does my position, their team does Kanban, so I wanted to do a little bit of research on why they chose Kanban. They used to be a Scrum, but then they switched over. So Kanban is a non-disruptive evolutionary change management system. This means that the existing process is improved in small steps by implementing many minor changes rather than large ones. The risk to the overall system is reduced. The evolutionary approach of Kanban leads to low or no resistance in the team and the stakeholders involved. So the first step in the introduction of Kanban is to visualize a workflow. So kind of like the way you see it here, to do, in progress, and done. This is done in the form of a Kanban board, just like this, kind of consisting of simple whiteboard or sticky notes. Each card on the board represents a task. A classic Kanban board, there are 3 columns, as shown in the picture. To do, this column lists the tasks that are not yet started. Doing consists of the tasks that are in progress, and done, which consists of the tasks that are completed. The visualization alone leads to transparency about the distribution of the work, as well as existing bottlenecks, if any. Kanban boards can show elaborate workflows depending on the complexity of the workflow and the need to visualize and examine specific parts of the workflow to identify bottlenecks in order to remove them. So a really important part of Kanban is the aspect to reduce the amount of multitasking that most teams and knowledge workers are prone to do. So encouraging them to stop starting and start finishing. So the WIP limits is basically the work in progress limits defined at each stage of the workflow on a Kanban board, and to encourage the team members to finish work at hand and only then take up the next piece of work, which I thought was kind of interesting. Here in the slide, I kind of show the difference between Scrum and Kanban, and this is where I think it's really interesting because the cadence, so like when I was talking about iterations for Scrum, it's usually 1 to 2 weeks. Kanban is a continuous flow, which is really bizarre. It just keeps going. And so the release methodology, again, same thing, continuous delivery. Like they're not delivering at a certain point, but they're just continuing to deliver. They also have no required roles, so there's no product owner, no scrum master, no development team. And so I'm not sure how the hierarchy works there with Kanban. I would have to do a little bit more research. But the key metrics, so velocity for Scrum would be like how many hours we can take on each week based on how much our employees can work that week, and kind of based on how much we've usually taken on per iteration as far as work. And then the change philosophy, teams should not make changes during the sprint, versus Kanban, changes can happen at any time, which I think that just like blows my mind. All right, extreme programming. So extreme programming is actually, I was very surprised that it's actually pretty similar to Scrum. It's an agile software development framework that aims to produce higher quality software and higher quality of life for the development team. XP is the most specific of the agile frameworks regarding appropriate engineering practices for software development. So that's kind of important to note when like looking at Scrum versus XP is the engineering practices. That's really, really important in XP. So talking about the roles a little bit, just like I have listed here, the XP customer is expected to be actively engaged on the project and ideally becomes part of the team. And I think that's really interesting because with Scrum, our project manager is more kind of interacting with the client versus XP, and right here, the customer is almost part of the team. So moving on to the developer, because XP does not have much need for role definition, everyone on the team, with the exception of the customer and a couple of secondary roles listed, is a labeled developer. So developers are responsible for realizing the stories identified by the customer. So stories, just for a little bit of context, stories or a story is basically a piece of work. It's like a little mini project. Because different projects require a different mix of skills, and because the XP method relies on a cross-functional team providing the appropriate mix of skills, the creators of XP felt no need for further role definition. Moving on to tracker. Some teams may have a tracker as part of their team. This is often one of the developers who spends part of their time each week filling this extra role. The main purpose of this role is to keep track of relevant metrics that the team feels necessary to track their progress and to identify areas for improvement. Key metrics that your team may track include velocity, reasons for changes to velocity, and amount of overtime worked in passing and failing tests. Oops, one more, sorry. Lastly is the coach. The coach is usually an outside consultant of someone from elsewhere in your organization who has used XP before and is used in your team to help mentor and the other team members on the XP practices and to help your team maintain your self-discipline. So the main value of the coach is that they have gone through it before and can help your team avoid mistakes, and most new teams make, which I think that's really cool. So I found this really cool map. I don't know if you guys have, or any of you been to Europe, but there is something called a tube in London, and probably in other places in Europe. And this is kind of like what a tube map looks like. So Scrum is this red line right here, and extreme programming is this pink line. So it kind of shows how extreme programming and Scrum line up. So both extreme programming and Scrum have daily meetings and iterations. I thought that was kind of a cool way of looking at it. And then I wanted to kind of look at what's the difference between Scrum and XP. So the iteration length, I found one source that said Scrum could be between 2 weeks and 1 month. I don't know any teams that would go all the way up to 1 month, but I would say that XP and Scrum are pretty similar in iteration length. So how does XP handle changes within the iteration? Amendable, so they're amendable to change within the iteration. If the team hasn't started work on a particular feature, a new feature the same size can be swapped. I would say that this is also pretty, well, at least for my Scrum team, pretty applicable as well. So depending on the Scrum team, some of them are really strict about the commitment that is made within the iteration. Some are closer to this priorities of the features. So the product owner, product manager prioritizes for Scrum. The work is in a strict priority order, and features to be developed are prioritized by the customer, which I think is really cool. Engineering methods, we don't prescribe any engineering methods. Everybody is kind of doing their own thing. And Scrum has a whole bunch, XP has a whole bunch of different engineering methods that they use. Test-driven development, pair programming, simple design, refactoring. Like there's this whole list I saw online. This is just some of them. And lastly, we have a Cape buffalo goring a lion while the lionesses watch. Aww. There we go. Ta-da! Littman, you're muted.
Look where it's going too. It's like in the gut.
Yeah, that's why I picked it out. I figured you would like that.
Man, so good. All right, questions.
Questions. Let's hear them. I feel like that went long. I apologize.
I have a small question about your Scrum team.
Yeah.
Does it happen, say, if you finish up your task before the time was given?
Mm-hmm. Yeah, there's been times where we're like 3 days left in the iteration, and the devs are like, we don't have any work. We're all out of work. All the work that we started at the beginning, we've actually finished before the deadline, I guess you could say. And it would be my job to look in the backlog and see that, make sure that it's prioritized, that my project manager prioritized it, and then I can ask her and ask my dev manager, be like, it looks like these stories are high priority, they're looking for work, can I bring these in? But when I, let's say like a couple more years under my belt, I'll be able to pull stuff from the backlog for the devs to work on when they are bored and looking for new work. Does that kind of answer your question?
Yeah.
Okay.
Just out of curiosity, is anyone else talking about Agile and Scrum?
I will talk a little bit, but just no. I'm talking about pair programming and mobbing specifically.
Yes, thank you, Alexis. Brilliant. All right, I'm so excited to hear this. That's awesome.
I don't know what you guys are talking about. How popular are the different methodologies that you presented? I've been talking to my boss about doing Kanban at Concordia. We don't have any sort of development methodology that we're using right now. Like, do you have a sense of which one is like, okay, the industry, everyone's doing this?
I have no idea. I mean, I was looking online also to like add a slide, like what are companies using right now? What are like the big name companies using right now? And I think that there's so many different methodologies that it really depends on the product, right? Like you really should pick a methodology that will benefit the product that you're putting out, right? But as far as the most popular, again, kind of depends on the product, but Littman, do you know of what the most popular methodology is?
I guess my gut feeling would be Agile with Scrum, but I'm just pulling that out just based on that's what everybody talks about. So that would be what I would say.
I think there are a lot of places that still use Waterfall, but
I wouldn't call, it's possible that it's possible there are many places that still use Waterfall. So maybe in terms of the numbers, a Waterfall might still be competitive, but I don't think in terms of popularity. I mean, I think places that are still using Waterfall are probably stuck in a situation of, do they have time, money, or resources to transition to something more modern, as opposed to it being better. So my gut feeling is it's probably Agile.
I have something to add on it's not actually a question, but since you guys are talking about the Kanban, I worked with Kanban.
It's actually pronounced Kanban, just for you guys.
Kanban?
Potato.
We call it Kanban at CW.
So I have my excuse. In Portuguese, we say Kanban. So.
Oh, I like that better. Let's use that one.
So it's used more for continuous improvement. So this is when you said that you can actually change the plan anytime, and it just blows your mind. It's because since you're using for continuing improvement, you can actually just realize that you have to plan it again, and then start moving over and over and over. It's not continuous like forever, but it's meant to.
Okay, gotcha. That's cool. Thanks for the insight. I appreciate it.
Can you guys hear me?
Yeah.
I have a question. What do you do with ongoing tasks? You have the same type of task every sprint. What do? Do you finish in every sprint, recreate it, or
Yeah,
it's make an epic out of it, right? So.
Right. It's like we usually end up creating like a feature where we're continually, every sprint, again, it's a new story that needs to be completed. Performance improvements, for example, like we need to do a performance improvement, or what's the word? Starts with an R. But like testing something specific every iteration. There will be a new story created every iteration. So it doesn't roll over. It's a new project every iteration.
Regression.
But yeah. Sorry, what?
Talking about regression testing?
Regression, yes, that's the word. Regression testing.
Anything else? Other questions? All right.
Yay. Thanks, guys.
All right. Who wants to go next? Anybody who thinks that their presentation is specifically compatible with what was just discussed, that maybe it makes sense to just pick up from where we left off?
Mine is a little bit.
Okay. So why don't you go?
All right. 1 second. Everyone can see that, right?
Yep.
Yep.
Yeah. So software engineering. The software, we will talk about the software characteristics first. There are like software characteristics. Software is defined as a collection of computer programs, procedure, rules, and data. Software characteristics are like 6 major components: functionality, efficiency, reliability, usability, maintainability, and portability. In the functionality, there are 3 main components. There are suitable, accuracy, interoperability, compliance, and security. This is the uh, characteristics. The reliability, that means recoverability, fault tolerance, and maturity. Efficiency means we should do in time and in resource. Then in usability, we should its understandability, learnability, and operability. For portability, it should be like minimum change we can portable the software. It should adaptability and replaceability. Software develop life cycle. The software develop life cycle is an old term but used for the describe the sequence of activity and task with the software development process. There are six main processes for developing the software: analysis, design, implementation, quality assurance, development, and support and maintenance. Analysis will take detailed requirement with guarantee that the task will be set correctly, and in practice, you will get exactly what you need. The as analysis is the first step, there the software, there we can get a detailed requirement that the task will, what tasks should be like product co-op, what resources are available, what are the ways to solve the problem. These are all part of analysis. Then design, the second stage, we should have an initial idea to begin and develop the function system. This is a simple like prototype. We can make a simple design of that. Then in the third step, it's implementation. After approving from the user, we can start for product and design with hardware configuration. Then fourth step is quality assurance. This phase is for the testing with the real users. Like we have to give some our co-workers for some feedback and for some real error or something. Then in 5, there is a beta testing. Like for the real user, they will use for some times and they will give a feedbacks. For the support and maintenance, the last phase, that phase is like after we give the software, there is any error correction or after sales service or any updation. These are the basic 6 types of software development cycle. Now the basic software development life cycle, there are some models which are like waterfall model, spiral model, and V-shape model. There are many more, but we will talk about 3. Waterfall models, as we see that it has a 6 part. It requires analysis, system design, implementation, testing, deployment, and maintenance. For waterfall, requirements are precisely documented. This is like for the big projects, and it costs a lot of money. The product's definition is should be stable so that it will be give a definite result. This model can be used for like the user should be perfectly known the product that I know this type of software. Then he can't change. Otherwise, it costs a lot of money. There is a spiral model. There are 4 types in this spiral. First is determine the object. Second is identify the risk. Third is the development and testing. And fourth is the plan and next iteration. This spiral model is it's for like customer, they are not sure about the product or what they want. Like they are not, sometimes they are not sure that what type of software they want. So this type of model we can use for them. Like first stage, we will require all the requirements from the user, then we will make the prototype. If the user approve, then we can get a second, all the verification and development and give a second prototype. And then after all the, if he approve, then we can make him the software. Otherwise, the prototyping cases is the best for the user. They that cannot specify, like customer is not sure about what they want. And if if this prototype we can change, like major edit can be done in any way, any time. Like on the second phase, we can change some product, like we can start from over. It's not like too risky. The third one is V-shape model for software development. The V-shape is like perfectly planned model for the software, like requirement specification, high-level design, low-level design, coding, unit test, integration system, and accepting testing. This is like planning all of them. It's very strict. It's getting a very strict results. For the small and good projects, it should be work perfectly. The testing and verification is done irregularly, so it's like kind of that. Here is the comparison graph that that we can see that waterfall is more famous, or it is like a more usable in the companies. Then it's iterative, then spiral, then Scrum, and Excellent program. We can compare the quality also, same as it has a high servability defects, but the waterfall is like famous one. So the first introduce of the waterfall was done by the Mr. Dr. Wilson V. Royce in a paper published in 1970. The waterfall model is a software development process. The waterfall model emphasizes the logical procession of steps by taking throughout the software development lifecycle, much like the cascading steps down incrementally waterfall. Yeah, any questions?
So that graph you had a couple slides ago with, yeah, that one. Do you remember what the
It's like
publication?
2019, I think.
Okay, that's interesting.
Last year.
Yeah.
Interesting.
Yeah.
So that answers our question from the last
Yeah.
presentation.
Yes.
But I think the Agile must be more popular around this years. But the waterfall is like running around from the years and years. So I think.
Yeah, Agile's just like the newest thing. So no one's probably going into waterfall anymore. It's just around still.
Mm-hmm.
Yeah, considering that companies spend a lot of money to implement a new methodology,
Yeah.
they have
Right.
to use all the resource as much as they can. By changing to something new, a bit more cost effective, I guess.
All right, other questions? All right, good.
Yeah, thank you.
Can I go next?
Ooh.
Me? Camila?
Can I go after Camila? Just think mine has a lot to do with that. So.
All right, so we already have the next two lined up. So I guess.
Yeah, so do you want to, I'm just going to go now because I have the SPRO model that's mentioned. Do you want to, if you have like more things to type?
No, my presentation is, I have an overview of a little bit of each, but I would just skip so I save some time since he already explained all of them. I have a tendency to run out of time, so.
So actually, my presentation today is gonna be very different probably from what you guys are going to present, because today I chose a topic that's right in between software engineering and that involves a lot of ITIL to it. And It is change management. It's an essential part of the software lifecycle, and we usually don't learn at school, and they don't officially integrate that on books, the change management to the methodologies that we have in software engineers today. But it is essential for us to know when we go to the market and we start working that change management in projects and after software delivery is essential to guarantee goals and control of the cost of the projects that we are creating, maintaining, and generating. So today, I will just give an overview of software engineer, change management, impact of change, the Scrum model that was previously explained, and the importance of change management. So I'm just going to go with a very specific part of software engineering, but right there including the methodologies that you guys are going to explain to show the importance of this. So, I don't know what's going on my computer. Software engineer is defined as a process of analyzing user requirements and then design, building, and testing software applications which will satisfy those requirements. The main idea of software engineers is to help companies to obtain a software which is reliable, works efficiently in machines, and especially inside the budget that the company has for that. And there are many methodologies used for software engineers, and two of the most famous one already was said before was Agile and the Scrum for Agile that we have today, and none of them we really talk specifically about change. And for this presentation, just keep in mind that change is something that is going to happen in every project and every stage of a software life cycle, before and after. So let's go to the definitions of software change management. Software change management is a process of selecting which change you should be encouraged, which change you should allow, and which change you should prevent. And according to and we're gonna authorize or not authorize according to the project criteria as schedule and cost. And there are a lot of things that can affect a change, can be affected through a change, which is the delay of a project, the change of a project, and the cost that that project is going to have to change. However, change is not really only negative for a project. It can be beneficial, but it's important to define what is really beneficial. However, we need to always remember that changes are necessary or unreliable, or they can be really costly. For example, you should not have too many changes on embedded systems, which is what we are working right now. You don't want to have your car being recalled every month. You don't want to have have to update your apps every week. But however, there are types of softwares like the software I work with, or maybe the software you guys work with, that probably are okay to have small and short releases every day, and that would not be a problem at all. So we have different types of changes, and changes need to be limited and defined according to each use of a software. So we have the differentiation where it comes to the change and the change needs of each software. Here I tried to define so I did not find much fluxograms for change management. So I tried just to draw a little bit how usually change really happens. So usually you have a request, and you have this I put a request form here just as a joke because it's really a joke. My department does change a request here. They take like 5 changes to make a change template. And after this request, we have impact analysis because we also need to change to calculate impacts, especially for applications that are kept on premises. And we have to approve or deny. So then we have to have the implementation of that change that's usually done on dev. And then we have the review. Then we have the release to production, because really the change, after a change approval, we just need to put in production. We have development, we have tests, then we have the production. The main idea is to control the production environment, because this change can have any type of impact, right? Especially if you're doing a change to a production server, for example, and that change is going to impact a little bit the performance of that server from that software itself, or that software is called by many other softwares in the company. So that's the type of impacts that needs to be evaluated. And for that, we have this whole view of change management on a project. We also have a type of software engineering methodology that's going to cover the concept of change management, which is a whole department in companies that's going to actually review, not only approve your change, but it also uses the Scrum model. The Scrum model is really, it's kind of a mix of the Agile and the Waterfall model. And as was said before, they have it's divided in 4 here. And the first one is just to determine the objectives, then evaluate alternatives, then develop, then plan. But it starts when you request a change. Then here you have the whole prototype that goes, and you have the model, then you have the delivery of it. And this is basically the type of model that most companies they use to control the changes that you guys are going to request for your software inside the company. And the main goal is risk reduction. When you are working with a product and you have to make a change to that product, there's a bunch of risk analysis that needs to go through to make sure that you're not just creating more problems and making people lose money for having developed a work that needs to be changed, or shifting too much the need of the software that you're working with, developing and using. So the impacts of change can be calculated differently, as I said before, whatever you guys are using. For example, DevOps, I think you guys might work with this. You can release, commit small changes often than if you're working with products on premises. So we need, it's easier to evaluate changes on DevOps than it is if you work with a huge evaluation of a code of a change on premise that's huge, bigger than the DevOps release. And in guided system, you have to work while you still before the release to make sure that the change is not going to be affecting the product too much. So we have all these differentiations and these different types of softwares that needs to be evaluated. And to conclude, change is important because it helps saving money to the company, because avoids shifting too much the idea and objective of your product. It helps not losing the original purpose of your software. Also avoid Wild West platforms that people goes and create and delete in whatever they think. And it help infrastructure records when there are on-premise development. change is in fact because after release, your software is going to go through a lot of different ways to be kept and to improve. And especially if your software is a premise software, it's probably going to change through the life cycle of the project, where what database lives, what server it lives, and, or what WebSphere, whatever you guys are using, and you need to keep a historic of it. And the only way to keep a historic of what your software history is through change management. And a golden tip is always request and document your changes. Any questions?
I have a question actually.
Yep.
I think your presentation has a lot to do with what I'm gonna talk as well. So I was wondering, you mentioned about that changes are not exactly bad; they can be good things. But I don't know if you're referring specifically to like a scope in a project, the change of the scope or the change of the requirements. But don't you think that some changes?
I am specifically. I apologize that I'm not feeling good today. I apologize that I jumped, but all these changes that I am basing is basically the first step of any methodology of software engineering, which is requirements. I'm basically talking the changes that's direct to requirements. So we have original requirement for any project that we're going to develop. And those changes are happening in the full life cycle of that project. So we have a type of change like this graph here that should happen while you're still developing that project. And we have changes like this that's after release, that's all controlled through departments that use softwares and everything in big companies to control what's being changed according to the main goal of its software that's being used, developed, and changed. Does that make sense?
Yep, it does. I was wondering, I mean, from my point of view, depending on the methodology, of course, some methodologies like Spiral, they need this change to happen all the time, but in some cases, lots of this change could be avoided with a better understanding of the requirement, you know.
Yeah, I think it's more, it depends what type of development you're doing. Like I said, for embedded systems, you don't want to recall your car every week to update your system, right? So that's something that you need to plan before and use a change management, even to see if you're changing and adding to your software on the right time, and that's not gonna shift too much your software. But yes, that is, I think it's applicable for each situation. I try to make it as short as possible because it's a very small topic, but you can talk about it for a long time, especially because honestly, I studied software engineer for a long time, but I just learned the importance of change after I started working, actually my recent job. So that's not something that we usually face when we are in school or if we are not really sitting out there and seeing how all these teams work together to try to keep historical or maintain a company goal, for example.
I agree.
Any questions?
Anything else?
At Northwestern Mutual, do you have a methodology for this?
They do. They have a whole department of change management there. They use share well right now for change, to help on change management for the operations, but they are changing their change management structure to ServiceNow, which is where I'm working.
Which is good because their ShareWell application is awful right now.
Yeah, so I am working a little. So I am working so I'm doing the mapping, and I'm working on creating the analysis for impact analysis for the change process at ServiceNow. I think the implementation is probably starting soon. Not sure. It's a huge project.
This sort of thing also applies to, I do some software engineering, but I do mostly database work since I'm a DBA, but these concerns actually exist in data modeling as well. And, you know, if you do things wrong in your database, you're going to have all sorts of strange impacts and unintended analysis. So you have to change things quite well. Because Concordia is so small, we don't have any sort of methodology where it's like, here, fill out this form. Sometimes it's just kind of like the loudest VP gets what they want. It's like DBA will say, oh, this is a very bad idea and here's why. And it will not matter. But yeah, no, this is an interesting topic. I think this applies not only in software engineering. Well, I mean, I suppose data modeling is a subset of software engineering. So I wish we had time and staff to follow this model. Typically, we're more reactive to this.
So there I think they are using this pro model, if I'm not mistaken, right now. Yeah, that's what they do to approve their changes.
I have a question, Camila.
Yeah.
How much of this information did you get from the recent change management e-learning that we all had to take at work?
None. I did not take it. I did not take it yet. But it's because I work very close with the change team right now, because they are all shifting to the platform that I'm working. So that's why I know some of this stuff.
At least your job knows what change management is. Good for your company. That's great.
Not sure if they're using it, but we're learning.
All right, any other questions?
Thank you.
All right, so Priscilla's up.
Me?
And then anybody except Alexis.
Wow.
Alexis is going next.
Okay. So, wait, can I start my timer here? Can you guys hear me?
Yes.
Okay. And can you see me?
Yes.
Just needed my timer because you know I'm not good at managing my timer. Today I'm going to talk about communication skills as a core part of software engineering. Why is it loading? Oops. I think I'm gonna go like this. Can you see well, like small like this? Or
yeah, we can read it.
Okay. So, as I was told before, software development life cycles in software engineer, and it is a process that divides software development work into distinct phases to improve design, product management, and the project management in general. And it's also known as software development life cycle. And it's not showing the picture. I don't know what's going on. Guys, I have issues with my presentation. Sorry, let me open here because I think I
Try
downloaded.
refreshing the tab.
I was, but I have the presentation here, I think in PowerPoint. It's gonna be easier. Yeah, usually I present like this, so I think.
Try to click on the present button, right top.
I think, yeah, now we're good. So requirement analysis, design, development, testing, and maintenance. This is the software development lifecycle. So as it was said before, we have tons of methodologies like Waterfall Model, V-shaped model, prototyping model. And I want you guys to...
Thinking that we're not seeing your slides change.
Really?
It still says software development lifecycle slide.
I would like stop sharing your screen and try resharing it.
Yeah, that's a... I'll share. New share. Did I close it? I think I closed it. Can you see it now?
Nothing's changed.
Are you kidding?
Now you're not sharing your screen, so that's progress at least.
Okay,
Well, then you're muted.
Sharing.
Yeah, I stopped her sharing.
Okay,
Now
so
try to share again.
can I try to share again?
Yeah.
Okay, do you see my screen now?
It says software engineering, communication skills, blah, blah, blah.
Yeah, is it changing the slides?
Changed.
Okay. So we have all the, I apologize for that, guys. We have all those development methodologies, and I will show a couple to you. And I just want you guys to notice that all of them has some requirements or analysis, which is the first step that we're gonna talk in this presentation. So the focus here is just to show you that all models are all the methodologies have some planning and some requirement analysis. Prototyping model has planning, initial planning, requirement. Evolutionary prototyping model also has the initial concept. And the Agile model has the backlog, and which is the beginning of the process, but to get the backlog, you also have to analyze requirements in the project. And this is all because there's a very important part of initiating any project. It's understanding the stakeholders' needs. And I'm sure if you work with project, you already have some situations similar like that, as when you think that you understand what the client wants, but sometimes not even the client know what they want, and you discover that in the middle of the project, and then you have to replan and redo. And in order to avoid the changes that are unnecessary, avoiding the change management that Camila was talking about, in avoiding rework, and in order to avoid spend money and time on something that is not actually required, it's very important to understand what the stakeholders really need. And this is requirement gathering. That is the process. The process is not as straightforward as just asking the stakeholders what they need or what they want the system to do. As in many cases, they are not aware of all the possibilities that exist. They might, and you know, that some possibilities might be limited by what they see, what their perspectives are now, but during the project, they might change this perspective and require more things and more things. So it's very important to set all the expectations in the beginning. And what techniques can be used for that? There are a lot of requirements, techniques like interviews, questionnaires, user observation when you have already a software, something that you can observe and see what the users actually need, what need to be improved, workshops, brainstorming, role-playing, when you pretend a situation is happening, so you can pretend, you can actually analyze different scenarios and use case scenarios, and even prototyping in the beginning of the project. And why communication skills are a core part of software engineering. All the technical skills in the world are useless without the ability to communicate. I found this phrase in one of the research, one of the articles that I read, and I thought it's very interesting. I feel like in a technical world, in the IT world, sometimes or interpersonal communication skills are abilities that are underestimated. And in fact, we need them to training and to be trained in any new skill that we're learning. We have to actually have interpersonal communications to understand what is being shown to us, and also to train someone to take over our tasks. Collaboration, team working is very important in IT as well. Mostly for projects and defining scopes in project, ask the right questions is very important. Effective listening is very important, which means you really have to listen what your clients or your stakeholders are asking for, because sometimes we have that idea already in our minds, what we need, what we think this project is, and sometimes your client is asking you something totally different and we just don't listen. So effective listening is very important. Written communication is also important. We have to be able to write, make notes, and put everything together in a project, so somewhere where all this information can be written and can be passed through the team in the future, or mostly when you have a new person join the team, documentation is very important as well, and this is all part of the communication skill set. And also confidence to ask again and again until you understand what the client is asking for, and also be able to describe a situation from a user view. It's also very important. So soft skills like flexibility, understand the stakeholder universe, clarification, and be comfortable asking the same question in a different way. As I said before, asking over and over until you understand, asking from a different perspective. When I say understanding the stakeholder universe, one of the articles that I read, it was showing some real world situations in projects, and this guy was he was a project manager, and he was saying that his process with his team was to do, like, you know, some sprints, some short meetings every day. And he noticed that with this new team that he was working with and with the stakeholders, this methodology that he was using, it wasn't exactly agile, but it was something similar. He wasn't following all the steps of the agile, but it was something similar with sprints and the daily meetings as well. And he noticed that this kind of methodology wasn't working well with the stakeholders that he was having by that time. So you have to be flexible to change your tools depending on the project and depending on the needs. And this is the key, how to improve my communication skills for software engineering perspective. And I read a lot about this, and these are some things that I found very interesting in the articles, that start by working on your listening skills. As I said, sometimes we have our mindset, we have this idea of what we want to build, what we want to do in this project, and sometimes it's not what the client needs or the stakeholder needs. Express your ideas through public speaking. Take every opportunity that you have to speak in public, like these classes are amazing for that as well, because we're having the opportunity to talk with our classmates and actually, you know, practice public speaking. And always strive to empathize with others. Try to always think how they're thinking and try to put in their place and try to see with the client or the stakeholder's eyes their perspective and their expectations. And that was it. Any questions?
Questions?
I think I went over my time a little bit.
No, you were good.
Okay.
That's why I'm a little bit shocked.
Well, since I didn't have to explain the methodologies, because
skip 200 slides. Your time was good.
Nice job, Priscilla. I liked that.
Sorry, what did you say?
I said nice job. I liked that.
All right, so no question. All right. All right, so anybody but Alexis.
Can I go next?
You can go after Alexis.
I will put my own mute because I have to make his smoothie. Sorry.
But yeah, you can go next after Alexis goes.
Then I want to go.
No.
I'm calling my spot.
All right. Ani, you ready for this?
I'm so ready.
Okay. All right. So I decided to talk about pair programming and mobbing because it's something I actually do almost every single day. So in software development today, there is a thing called pair programming, but it still has a patchy adoption in the industry due to its benefits not being immediately obvious, but are more obvious in the long term. But it is so much more than just two people working at a single computer, but can be a very collaborative method for teamwork and high quality software. And it's actually been around since the first programmers. It goes all the way back to Jean Bartik, who was one of the ENIAC women. They didn't have role models or books on how to do the programming, so they decided to do it in pairs. Yet it still took 50 more years for pair programming to become a widespread term. It was coined in 1990s Kent Beck's book, which is an extreme programming method, and it's an introduction to agile software development practices. And so pair programming is one of those practices in there. And pair programming is when two people sit at the same computer and collaborate on the same code at the same time. It involves a lot of communication. So kind of what Priscilla's presentation was about, the communication is a huge key in software development and engineering. That is so true. So you need to be able to work on a task together, but you're not just working on the task, you're also going to be planning and discussing the work, clarifying ideas, and figuring out approaches to get better solutions. And a lot of people don't really understand how pair programming works, but there are many different styles. The most common style that I've witnessed is the driver and navigator style. So the driver is the person at the wheel, so the keyboard, and then they are focused on the goal at hand, whereas the navigator is the observer and is generally figuring out the higher level things, the larger issues, bugs, making notes, and figuring out the potential next steps or obstacles. However, at my job, we do it a little differently, where the driver literally types exactly what the navigator tells you to, especially when we're doing mobbing. But a more common flow of that is you basically start with a task, agree on one tiny goal to do that can either be done in a unit test or a commit message. Switch keyboard and roles regularly so you can keep the participation and energy levels up. And as navigator, avoid the tactical mode of thinking. Leave the details of the coding to the driver. Navigator's job is more to step back and complement and think more of the medium-term thinking. So then there is the ping pong method. So that is, ping would be like developer A, you write a failing test. Pong is then developer B, which writes the implementation to make it pass. Developer B then starts the next ping, so switching places. But you can also do it where after the Pong part, you guys refactor code together before you start. And this can also follow the red-green refactor approach. Then there's the strong style pairing. So the rule for this is for an idea to go from your head into the computer, it must go through someone else's hands. So that's kind of where like you're basically telling them exactly what you want them to do. The navigator is usually the person who is much more experienced with the setup or task at hand, while the driver is the novice. The driver totally trusts the navigator and should be comfortable with incomplete understanding and ask the why after the implementation session is done. While this technique borders on micromanagement, it can be useful as an onboarding tool to favor active learning by doing over passive learning by watching. And it's great for knowledge transfer, but it shouldn't be overused. Then there is the pair development. So this is not so much as a style, but more of like a technique that you can use in the styles. So basically you want to understand the problem. You want to read through the story, play back to each other how you understand it, clear up the open questions or potential misunderstandings with the product owner. And if you have a definition of ready or a definition of done in your team, you need to go through that and make sure you understand everything that needs to be done for that. Then you come up with the solution, brainstorm what solutions you think you can do for your problem. You can either do this together or you can split up and then present your ideas to each other. It all depends on how well defined the solution already is, but also on your individual styles. Some people like time to think by themselves, so they might be able to get some more out there. Then you want to plan your approach. For the solution, you choose what the steps you need to take to get there are and their specific order that you need to keep in mind and how will you test it. Really, you should be writing these steps down so you make sure you don't miss anything. Things you also will need is time management. So obviously we all have meetings every now and then. You need to make sure you guys coordinate your calendars and know exactly when you guys can set time aside and pair. Then there's also pair rotations. You don't want to be the one driving or the one navigating the whole time. You generally want to switch off. For pairing, they generally say 25 minutes is a good time. And then also you want to plan the day. That kind of goes with the time management. You want to know exactly what you're going to be working on and you want to know when. And then your physical setup. You want to make sure that you're at a space that you both have a comfortable amount of space. You don't want to be cramped right next to each other. You want to make sure you both can see the monitor or the screen that the driver is using. Things that you want to avoid are like the drifting apart. So when you pair, make sure you avoid reading your emails or using your phone or doing other work. You want to stay engaged. You also want to watch out for the micromanagement mode. It doesn't leave room for the other person to think, and is frustrating experience if they feel they are constantly being micromanaged. Then you also want to apply the 5-second rule. If the driver is doing something wrong, give them 5 seconds or a designated amount of time that you guys agree upon. I've also seen 3 seconds to get the driver to correct themselves, for they might already be thinking of it and you don't want to interrupt their flow. Make sure you also share the keyboard. You don't want just one person hogging, for it can cause a lot of tension. And then teams really committed to making their work get done in good quality will sometimes pair for 8 hours. But that's not really sustainable. You should be taking breaks, and it can become very exhausting. It does not even work in practice because there are so many other things you do need to do throughout the day, such as checking emails, having one-on-ones, going to meetings, and so on. The benefits, though, are knowledge sharing. So, for instance, if you are the driver and you're with someone who knows better of what they're doing, them telling you what to do and helping you type the code and you actually being engaged can help you learn. I've actually learned so much through the pairing and mobbing process with this. And then also the collective code ownership. When you're individually coding, you're basically responsible or to blame for that code. Whereas if you're pairing or you're doing mobbing, you guys all then have that collective ownership of it. And for pairing, it's 2 modes of thinking. You always have heard the phrase, 2 heads are better than 1. Well, that's basically this case. You have 2 eyes looking at it. You have twice as much of a responsibility of making sure there's not mistakes, and that much of a chance of preventing them as well. And then there is reflection. It just helps you see okay, what you need to learn, as well as code reviews. You're going to be going through the code, seeing stuff, you're able to ask questions. It helps you stay focused since you guys are both being engaged, and it can help keep the working in progress low, for you guys would be focusing on less tasks at once. And I know some companies or some teams can have problems where they have way too many tasks or stories currently in progress and not all of them are getting completed. Challenges, on the other hand, so it can be exhausting. When working alone, you can take breaks whenever you want. However, if you're pairing, you basically are forced to sit there and focus for longer stretches of time. So you need to find common ground with the other person's rhythm and ways of thinking and stay focused, but make sure it doesn't get too intense. It can also be hard, kind of how I was saying, it can be intense. You need to communicate constantly, and it requires empathy and interpersonal skills. You might have differences in techniques, knowledge, skills, extraversion, personalities, or approaches to problem solving. Some combinations of those might not match well and give you a rocky start. But take some time to invest to improve your collaboration and help each other not struggle. There can also be interruptions with meetings, which can always interrupt your flow. But that's just something that you have to deal with. Then there's also different skill levels. Like I said, that can help with knowledge sharing, but at the same time, you need to learn where someone is rather than making assumptions that they already know what they're doing. There also can be lots of unknowns. If you don't know everything you need to get done, you really need to take a step back and make sure you guys have everything planned properly. And there's no time really for yourself. If you're constantly pairing, you're gonna want that time sometimes to just sit back and do the learning and stuff that you usually do on your own. And then the rotations can sometimes lead to context switching if you do it too often. And pairing requires vulnerability. I know for me, when I first started doing this, there was some things that when I was the navigator and I really didn't know what to do next, I was scared to admit it, but since I started, I've gotten a lot more confident in asking questions. So mobbing is very similar. Mob programming was first coined in the Extreme Programming XP community in 2003 by Moses Holman. It was used to describe the practice of code refactoring and a group of more than two. Woody Zuill began popularizing it in 2013 when speaking at developer conferences, saying his team of 8 members was mobbing full-time and shared the successes they were seeing. Mobbing is a software development approach where the whole team or most of the team works on the same thing together in one space with one computer or switching between computers. So the basics for this is the setup. Basically, you want to have one computer. You can either work on the same computer. My team, however, we usually switch. So like once we finish like something, like if I'm driving and I finish something on my computer, if one of my team members is going to drive next, they then use their computer and we just push the changes. It just makes some people more comfortable. They also say mob programming is best if it's between 3 and 6 people, or sometimes even 3 and 4 people. So you want to make sure you don't have too many people. Then you want to make sure you have the roles clearly stated. So there's the driver and the navigators. There can always be more than one navigator, but there can never be more than one driver. And then for mobbing, it's a little different with the rotations than pair programming. You want to try to rotate every 10 to 15 minutes. Make sure you use a timing tool such as Pomodoro that can help with this. And then most mobbing stations have a large TV or projector and then a larger table so you guys all can be comfortable. And then, is mob programming really efficient? Many may say it's not efficient to have 4 people working on one problem when you could have 4 people working on 4 problems. But in the right conditions, mob programming can be as efficient and often more efficient than traditional programming. You just have to think about efficiency differently. Since the Industrial Revolution, we have been thinking of efficiency as a one-type resource efficiency. We have ingrained into our brains that busyness equals value. Basically, if you aren't busy, you aren't contributing. But there is also flow efficiency, where resource efficiency is about how busy you are. Flow efficiency is about getting work done. One way of thinking about it is a traffic jam. Yeah, you're using the freeway, you are using every single inch of the asphalt, you're using all your resources, but you're not using the flow, you're not getting anywhere, so technically it's considered not efficient. So engineers have experienced paradoxical days. They are so busy, they aren't able to get anything done, which kind of sounds weird, but it's the actual case. So mob programming solves this problem, which favors flow efficiency over resource efficiency. Then there are the advantages of mobbing. It's very similar to pairing. There's the tighter feedback loops, the collective code ownership, fewer and shorter meetings, such as stand-up. You don't necessarily need to do stand-up every day if you guys are all working on the same thing. And then flexibility. So if somebody needs to like take a break or is on PTO for a day, it's not gonna stop the work. Like there's 4 other people or whatever that are still able to do the work without you there. And then speed. It may take longer for the initial creation of the code to get done, but because it's higher quality, because you have more people working on it, you don't have to do as much rework or deal with merge conflicts and knowledge silos. So you're just focused on getting the work done. Therefore, you're saving a lot of time in the long run. Drawbacks, on the other hand, and I know I'm way over my time, sorry, this is just a huge topic. So there's the perception barrier, which is the biggest disadvantage of mob programming. It's hard to change people's perception about the efficiency. So that's one thing that not a lot of companies are able to do, and that's why not a lot of companies are using it yet. And then remote work, I don't necessarily agree with this drawback because with this whole coronavirus thing going on, we've been kind of forced to do remote mobbing or pairing, and I feel it works out really well, but some people think it doesn't. And then hiding or deferring, so that kind of goes back to the confidence thing. You may not feel confident or might be stricken by imposter syndrome, say that they might not participate as much when they aren't at the keyboard. So you want to try to boost people's confidence, even if it means letting them code on their own for a little while. And then just really quickly, so I read a psychology article about this as well, and they basically, it said they observed teams that took regular breaks did a lot better. Also, if you let the navigator take control every once in a while, like know when to pull over as the driver. Always have a whiteboard to draw pictures on, because sometimes you just won't be able to convey what you're trying to say without a picture, as long as it can help you create thoughts and jog memories. And if two of you cannot figure something out, don't be scared to ask questions. Higher performing pairs have used this communication, which helps increase the transfer or knowledge transfer as well. And then if you operate at multiple levels of abstraction at the same time, constantly fitting in and out of levels of detail, this creates problems when building up large complex images in your head in high performing pairs. So you need to learn to deal with the little flags and reminders of questions and facts you unearth while all still being focused. So you can use lists for this, which is really helpful, but at the same time, most of the time the lists are not actually revisited. It's more of just, you know, like when you write it down, like you're automatically thinking about it and gonna remember it. And then if you're also running out of juice, make sure you change drivers. And all this psychology can be said with mobbing as well. So I guess in conclusion, do I think it's worth it? Yes. I've learned so much since I've started at Northwestern Mutual with pair programming and mobbing. It's really helpful, especially when I'm the driver and someone's navigating. If I really am not confident, or they just push me to try and be the best I can. And who should use it? Well, it really depends on the personalities of your team and whether they accept the fact that it can help them. It really depends also on how many people you have. I would say it doesn't hurt to give it a try, but in the end, if you feel like it's causing more tension and less work's getting done, then don't do it. Any questions?
Questions?
I might have missed it in the presentation, but who is using mobbing right now?
Well, NM is. Other than NM, one of the articles I read was talking about a study done. It didn't say what company, but it said like different teams in that company were doing different styles. And so they started doing that full time. I know it's still a very, very new thing. Like one of the articles I was actually reading was about how it's the next big thing. So like when Littman kind of said like the next up and coming stuff, like I kind of instantly thought about that because it's not a huge thing yet.
And where do you feel like you're in your stage of your career? Are you the navigator or are you the driver right now?
Well, so like I said, you rotate.
Yeah.
I personally prefer driving because it keeps me more engaged. Because I like know like if you're navigating, like, well, so for pairing though, it's a little different because if you're navigating, like you're still forced, like you're the only navigator, so you're still forced to be engaged. Whereas if you're mobbing, if you have too many navigators, like not everybody is going to feel like they're contributing, and so they might start doing stuff on their own, like on their own computers and not paying attention. So that's why like they say like mobbing sessions between like 3 or 4 people is best. And my team, when we first started, since everyone on my team was basically new to JavaScript and React, we had basically our whole team doing mobs. But now we have it down, like if we are mobbing, we have it where it's only like 2 small groups of like 3 or 4 people. So I prefer driving, but at the same time, I think that more has to do with my confidence level as well, because if I'm navigating or if I'm supposed to be navigating and I don't necessarily know like what to do, then I question myself and then I get uncomfortable, but that's something I'm like trying to work through. So like you still have to push yourself and do both positions. You may be uncomfortable in one or the other, but you kind of just need to learn to deal with it because it will help you learn.
What does a good navigator do then? Speaking from your perspective as a driver, where you prefer that, what's a good navigator do to make the driver feel comfortable, especially if the navigator is a more experienced dev?
So,
like what works for you?
So I guess I've seen a lot of different things, but like, so my dev lead, for instance, Littman knows him, Andy. He sometimes kind of makes me feel uncomfortable because like he'll start saying like, okay, you need to do this, and if I ask a question, he won't give me a straight answer, but he more kind of forces you to like think about it yourself and walk through it in your head to get the answer. So, sorry, my cat's climbing out of in a box and I don't know what the heck he's doing. It's distracting, but
Post it on YouTube. My kids will watch it and love it.
nah, my place is too much of a mess right now. He's just being weird. But basically, yeah, so Andy, like, he pushes me as the driver, like, so like if I'm, because like I said, like usually after a session, like if you have questions, you should ask. But when I ask, like, he pushes me to answer my own question. And if I like am struggling on the answer for too long, then he'll step in and be like, okay, like walk me through it. So I think that really helps because it does force me to think. But at the same time, most of the time we generally like say, like, it kind of goes with the micromanaging thing. Like we generally say like, okay, now type like console.log or like type the class, like, or whatever, because that was more of the practice of where the driver shouldn't be going rogue. And they should like be doing exactly what the navigator tells them to. So there's a lot of different ways you can do it, but it really depends on like your personalities and how you're comfortable. But I haven't had a specific way yet that I've experienced that I was like super uncomfortable with. Like if I was uncomfortable, it was more of just like my confidence level, but nothing like where I was like, okay, why are we doing this? This is really stupid type thing.
I've only had one quote unquote driver come through my department, and he was a football player, so he was really tough. So I was thinking through going back to Priscilla's presentation, I was like, would my communication skills be effective enough to be a kind and considerate driver? But anyways, that's why I was curious about that. Because that is a very interesting dynamic that you would get into, especially if you're a less experienced dev. I personally would find it a bit intimidating if I knew a really good dev was staring over my shoulder.
Mm-hmm. Yeah. It also doesn't help when you're typing with a bunch of people watching and then you start misspelling words all the time. Because we all have that problem.
Oh, yeah.
Mostly when you're not a native English speaker. Yeah.
Even native English speakers. This language is hard, man.
I spelled environment wrong in one of our programs. And we literally were running into an issue and we could not figure out what the problem was. And it was because I misspelt it in one place and the other places it was not misspelled, so it wasn't working. So it's a funny thing looking back now, but it's just one of those things with like syntax errors and spelling. Like you really got to make sure you're doing consistency. Ani, did you have any questions?
No, I really liked your presentation.
I know it went really long, but like I said, it's just so much to talk about.
I have a question.
Yes.
So can I ask you, in your company, do you witness, say, two very experienced programmer doing pair programming?
Did you say two experienced programmers?
Yeah.
Yeah, definitely. Like we kind of have a thing where like if it's something, like if it's something you both are interested in working on, or whatever. So like if, for instance, so a lot of the people on my team though are like fairly new, like I said. So we only really have one person who's been programming. He's been at the company for 14 years now. And then the next experienced programmer on our team has been there for 2 years. So it's a huge gap. But so like for me and some of the people that have the same amount of experience as us, we'll definitely pair together and we'll both learn. But I've also seen where like even the 2-year programmer who's very knowledgeable, he's really smart, will pair with our dev lead who's been there for 14 years. And so like they're still the two most experienced, but it's more of just like, okay, if they both want to work on like setting up like our routes for APIs or Apogee and stuff like that, they'll do that. So it's just more of like, if you want to work on something and someone already claimed that task, like we're encouraged to ask like if they want to pair, and then if they think they want to do it by themselves and like take on that challenge, like that's encouraged too. But there's definitely, you can definitely do pairing with any amount of experience pairs. Like you don't have to pair with someone that has more experience with you than necessarily. Like you can be with someone that has the same amount if you want. Does that answer your question?
I'm just curious, in what situation, say, very experienced and very knowledgeable person would say, do they want to tackle down a very difficult problem and settle it down as quick as possible?
Yeah, I mean, it's definitely possible, like, but kind of like I said, like if you were both interested in working on the same thing, yeah. Or for instance, if you were working on something by yourself, but you, even as an experienced programmer, couldn't figure it out on your own, you can bring in someone else that's just as experienced as you, like, to help. Because like having that second pair of eyes can always help too. You figure out what the issue is or whatever.
And one more question is, if you saying the percentage, how much time you programming alone compared with doing pair programming in your job?
Before the coronavirus incident, it was probably about 50% or more of my time. There were still things like where I would do my individual stuff. When I first started, we were generally mobbing and pairing all the time because we were all learning. But now that we're all working from home, it's probably more like 25%. Like it's more now only if I really don't know what to work on next because we're almost done with our sprint and all the tasks are either taken or completed and I want to like work with someone, I'll ask. Or if I'm working on something by myself and I like am at a roadblock and need help, then I can have somebody help me generally for pairing. So yeah, it really depends too on like how knowledgeable you are, because the longer or the more you learn and the more comfortable you get doing stuff individually, the less you'll probably do it. That's why it's mostly recommended as an onboarding thing, but it doesn't mean you can't do it as a knowledge transfer later on as well.
Okay, thank you.
Anything else? All right.
Okay, Dr. Lidman, can you hear me?
I can hear you.
Okay, thank you. Okay, just I was checking.
Okay. And then who said they want to go next?
Me, Ghalib.
All right, you are up.
All right, can you see my screen?
Yes.
Okay. Okay, so today I'll be talking about software testing. Why I choose this topic is because software testing is evaluation of software against requirements gathered from any user or system specification. It is basically conducted at the phase level in software development life cycles or anything like that. The definition of software testing varies with different authors. Basically, it is the process of executing a program or application under positive and negative conditions by any manual or automated means. It checks for the specification, functionality, performance, and it used to identify the correctness, completeness, and quality of any developed software. The main aim of or the objectives of software testing includes like uh, uncover as many errors or the bugs as possible in a given product, demonstrate a given software product matching its requirements, validate the quality of software testing using the minimum cost, and generate high quality test cases, perform effective tests, and issue correct problem reports. Then these four terms: error, bug, fault, and failure. Each of these are dependent on each other. Error is like error is, it is a human action that produces the incorrect result, that produces a fault or something like that. Then comes the bug or the fault, the presence of any error at the time of execution of any software system, or the state of software caused by any error. Failure is the deviation of software from its expected result. It is basically any event generated during the software execution. Testing lifecycle. So testing lifecycle includes a lot of stages. The first stage is the project initiation. Initially, when the project is like when it is in the requirement gathering phase, there are multiple things that need to be done on the test plan cycle. Test plan cycle, it is a systematic approach to test a system or any software. The plan typically contains a detailed understanding of what the eventual testing workflow will be. After that, uh, all the testing techniques has to list acceptance criteria, that what are those criteria on which each and every module of the function system or the software is accepted. Then comes the strategy and planning of the design test cases, in which the testing team has to plan and execute what type of test cases they need to make. Those cases may include identification of a specific requirement, test cases based on the success and failure criteria, specific steps to execute test cases, and all the test data. Then comes the defect tracking and bug fixing. In the defect tracking part, like for every module of the software system, there is a thing on like the tester have to test each and every module, execute every test case on that particular module, and try to figure out all the defects in it, and then has to report it to get it fixed. Then comes the part of review and audit. In review and audit, like all the reported bugs need to be rechecked and retested, and their review and audit reports has to be generated. On that criteria, acceptance and baselines are created to successfully deliver the system. Testing classifications. So if we classify testing based on by purpose, so there it is categorized with four things: correctness testing, performance testing, reliability testing, and security testing. By purpose means that uh, there are certain things in the software system that need to be tested based on their correctness and performance or their security. Second things come that by life cycle phase. During every software development life cycle, their testing needs to be done, whether it is a design phase, program phase, evaluating phase, or the acceptance phase. And classification with respect to scope states that unit testing is done or not. Each and every individual component is tested, integration testing, and system testing. Talking about the most renowned type of testing, the first one is black box testing. In the black box testing, basically it is also called correctness testing. Only inputs and output functionality is visible. Inputs are given and outputs are compared against a specification. No implementation detail of the code are considered on this level. It is also called data-driven testing. Target is to find incorrect or missing functions or the functionalities, interface errors, and performance errors with this thing. In black box text testing, we have no knowledge of internal program design or anything. Tests are based on the requirements and functionality. Another thing is white box. White box testing is the knowledge of the internal program design and code required. Tests are based on coverage of code, statement, branches, and other things. The structure and code are visible in this type of testing. Implementation is given more importance. Programming languages, logic, styles, functions are considered. The target of white box testing is to check control flow, looping, data flow, and all the nodes are traversed at least once. Then comes unit testing. Unit testing, it is generally done by the programmer. When the development starts, every developer has to add a unit test for every individual function or the piece of code that has been written. If created unit test fails, then the developer has to make some changes in order to search for possible errors within those things. Uh, Unit testing follows a white box testing logic from the program, and like if the test runs successfully, then that part of the code is successfully transmitted. Another thing is integration testing. In integration testing, once all the unit tests are performed, then integration comes. It is systematic testing. Produce tests to identify errors associated with interfacing. It has 4 types: big bang integration testing, top-down integration, bottom-up, and mixed integration. These these 4 type are like they are mixed together to form this type of testing. Then system testing. In system testing, the system as a whole is tested to uncover requirement error. It verifies that all system elements work properly and that overall system functions and performance has been achieved. It has like 4 types: alpha testing, beta testing, acceptance testing, performance testing. In alpha testing, it is carried out by the test team within the development organization. For beta testing, it is performed by a selected group of friendly customers that has to whom the company has to give some real-time scenarios to uh, to test the system. In acceptance testing, it is performed by the customer to determine whether to accept or reject the delivery of the software system. Performance testing is carried out to check whether the system meets the non-functional requirements identified in the SRS. Okay, so there are mainly 2 types of testing techniques. One is the functional testing and the other one is the non-functional testing. Functional testing is a type of software testing in which the system is tested against the functional requirements and their specification. Functional testing ensures that the requirement or specifications are properly satisfied by the application. This type of testing is particularly concerned with the result of processing. It focuses on simulation of actual system usage, but does not develop any system structure or any assumptions. So unit testing, integration testing, interface testing, system testing, regression testing, and user acceptance testing, which is also called UAT, falls under the category of functional testing. Non-functional testing talks about like it is a type of software testing that is performed to verify the non-functional requirements of the application. It basically verifies whether the behavior of the system is as per the requirements or not. It tests all the aspects which are not tested in functional testing. Non-functional testing is defined as a type of software testing to check non-functional aspects. It is designed to test the readiness of a system as per non-functional parameters, which are never addressed by functional testing. So like documentation of the project, installation and writing of the manuals, the load testing, performance testing, the scalability of any software system, these all things come under the category of non-functional testing. So that's it. Thank you. Any questions?
Questions?
No.
Going once, going twice.
Yes,
Oh, go ahead.
I would like to go.
Oh, no, Maddie's going next, and then Josh, you can go after that.
Okay.
But we're clapping now if there's no question.
Clapping now. It's clapping time.
All right, can you guys see that?
Yes.
Yeah.
Yes.
Yes.
You seeing the full screen?
Yes.
Okay, this is weird because I've never presented off of two screens before. And you guys can hear me okay? No comment, you can't hear me?
Yes, we can hear you.
Yes.
Yes.
Loud and clear.
Can't see you though.
Okay, so this was good how this order ended up working out because I am talking about software quality assurance, which kind of stems off of testing, so that works out well. You will see a lot of the same information and pictures as you have already seen tonight, so I apologize that I am not unique. Starting with the software development lifecycle picture. So for software testing, it's not a regulated profession, and in principle, anyone can be a tester. But what I'm going to focus more on is the quality assurance part of it. And so I read a couple, I guess, pages of this really long book that I'm going to share with you at the end because I thought it was really good for the parts that I read. The author brought up a really good point about how anyone can be a tester, but building quality into software has to be built within each part of the software development lifecycle, which is what this is for here. And so to do that, there really needs to be standards at every level. And one of the most important standards that you need to set is for what quality is going to mean at each of these levels. And so, again, this is another thing that you've already seen before, but quality can be defined in a lot of different ways, but some of one way that, or 6 quality characteristics that QA testers are looking to achieve and just look for in their system is functionality, reliability, usability, efficiency, maintainability, and portability. So that leads right into why is software quality assurance important. So quality is a critical aspect to business success, customer satisfaction, competitive advantage, and acceptance. And if you don't have high quality software, that could result in basically just the opposite of everything that was above. So financial loss, dissatisfied users, damage to the environment. It can even result in deaths. And even Alexis talked about this, how there could be need for rework. And even though not all software has the potential to lead in deaths, which is probably hopefully the case in most cases, software quality assurance is
is more than just important, it's necessary to have in any size company, because again, without it, there's going to be more rework, and there's going to be a more costly project. So next here, I have this diagram that I found of cost of software quality. And so this was a term that was coined in the 1950s. And according to the the cost of software quality concept, costs related to software's quality are classified into two cases. And so if you can see my mouse here, here's the cost of software quality. It splits up into control costs and failure of control costs. And so control costs are then broken down into prevention costs and appraisal costs. And appraisal costs include how much it will cost to prevent like failures and errors and mishaps within the code, whereas prevention costs include just investment in like the infrastructure. So even tying this in with other people talking about Agile, in some ways that can prevent rework if you're constantly getting feedback from your stakeholders. And then if you look on the other side down here, the other cost of software quality is the failure of control costs, and that gets split up as well into internal failure costs and external. And that's a little bit self-explanatory, but the internal failure costs are found and fixed within the company. And so this includes any of the testing done on a piece of software, which is kind of what the last presentation was talking about. And then external failure costs include all costs correcting failures detected by customers or the maintenance team after the software system has been installed. So next, I cannot have a presentation on quality assurance without talking about the capability maturity model. If you haven't heard about this before, it is a way to evaluate the work done by software engineers. So it is basically each of these levels describes how well managed and mature a company is and their processes. So going from level 1 to level 5 is the best here, and level 1 is the worst in terms of maturity. So this initial level down here, it's the company or whatever team you want to like evaluate with this model is very chaotic, and the products developed are often over budget and they're late. So I think it is very reactive here, as even I think Seth said that about Concordia, which is interesting. And so then that can be improved to go to the managed level, which is the second level.
Just our software development, not the university as a whole.
Thanks. So the second level shows that the products are getting better estimated and planned, but the software the software that is being created is getting more standards, but there's still a lot of room for improvement. So level 3, we're getting better, is the defined level. The defined level has more of a refined process for the design, requirements, implementation. There's kind of a process that is in place. Those standards are there. The next level is the quantitatively managed level, which is kind of a mouthful, but that occurs when there is an optimized process performance across the whole company. You can see here that processes are measured and they're controlled. So again, the company is probably doing well. They have a really good process. And finally, level 5 is the optimize or optimizing level, which focuses on the process improvement. And by this level, that means that a company is able to identify and deploy new tools and process improvements to meet needs and business objectives. So definitely probably a growing company, a very stable company. And I think that it is also important to talk about how this goes back to my, I didn't want to put this up here, but this is the seal of approval. Get it? All right, so this is the book that I talked about in my first slide. What, did someone say something?
I said, I got it.
Thanks.
But it's amazing.
Okay, so this is kind of a plug, but also like if you want to be like super interested in computer science and want something to read in all this free time because of the coronavirus, I was really impressed with this. This was an ebook. It's free. You can find it in the library, but I also realized that you can just follow the link. So I think Lippman is recording and you could probably go back and find this if you want. I said this, it's literally like 230 pages and I did not read all of them, but it was very interesting. And so highly recommend that. And let's next. I also cannot talk about quality assurance without mentioning this. And so if you have not seen The Office, I have been watching The Office. And this is Creed, and he was their quality assurance guy. And so that's another little plug. And finally, just because of Ani and our little competition, I have this. Do we have any questions?
Well, this isn't as good as the horn going into the lion's side.
I didn't want to include any blood in it. I didn't want to freak anyone out if they're a little bit queasy.
You don't think this is going to get some blood?
It will, but you can't see it.
I didn't even tell Maddie what the picture was. I was just like, "Get ready, Maddie. I'm after like this. This is a good one." We both pick lion pictures. It's so awesome. But your lion is doing better than mine was.
Thank you.
All right, questions?
I got a question for you, Maddie.
What's up?
What did you learn after doing some research on QA? What did you learn about QA that you didn't know before you thought that was kind of interesting?
I think it was more just like a realization. Like we don't realize how quality really, like I said in the beginning, it has to be implemented in each level. And so it's not just like the QA people that are in charge of building in quality. It's something that we have to remember as developers, if you are a developer. And so just like doing the research on it and realizing the impact that I have because of the quality that I do or do not build into software. And that goes along with like doing a lot of testing, and I really have not been good at testing, and every single day my mentor's like, "Did you test this yet?" And I'm like, "No." So it was more just like a reminder and realization of like all these different ways that quality is why it's important.
Cool. That's my only question.
Thank you. Other questions?
Going once, going twice.
Thank you.
All right, so we have Josh coming up next.
Yes. Yes.
All right, how do you do this? Stop.
I hope. Can you see my slide?
Yep.
Yes. So good evening to everyone. Today's my topic is artificial intelligence and software engineering. As every one of us, we know that artificial intelligence is a hot topic in the software development industries. Right now, the AI is what is performing the task. The task is simple, which required simple coding and sometimes without coding. But at the same time, people like us, those who are working in a tech field and in the IT field, they assume that AI is going to grow very fast, and in the future, the software developer will be dealing with complex issues, with the critical problem, writing a difficult codings. That's AI is going to be developed. So another thing is, what are the benefits of AI in software development? So today I will be emphasizing on 5 different benefits of AI. I will be explaining all 5 benefits one by one, and some of them are a little similar, overlapping. And even though in this screen you can see that all the benefits are there, high, medium, and low. These benefits are in the AI. If I will be explaining this one, I think 10 minutes is not going to be sufficient. So I would like to go slide 1. Slide 1 says, AI makes fully automated software testing possible and fast. As you see in the slide, one side it is manual testing, another side is automated testing. And we also know that it is very essential for any company or business to test the software before they function it. Normally, when we human test the software testing process is time consuming, and it is very costly also, because this is done by a human. Sometimes and also depends upon and how much software developer has knowledge to test the software. So my point is that software testing is done, takes a time, because every software testing software developer takes time, because they want to get success in the process of software testing. No one want to rush and do something wrong and get unsuccess. So other things I would like to suggest to you, as I think Galib was talking about testing process, unit test and integration test and system test. I would like to request if somebody come across to test the software for their company, if you have experience, you can go to the high level of testing. If you don't have much experience, I would suggest you to go the basic level of testing, which is unit test and then integration test and so on. But the point is that how the AI can help to fully automate software testing. In the future, what is going to happen when you write a program or code, or you create an app, you have to download your app, your program, your code into the cloud. And when you download, then there will be a robot. That robot is going to walk through in your all programming, coding, whatever you have done in your app, and robot is going to find out the problem, error, crash, and fault, whatever, and the robot is going to test it and come back to you within a short period of time, and they will give you result. So sometime it is going to be, so this is the benefits. So in this way, this is the great improvement of AI in software testing. Second is AI enables better developers. When I say AI enables better developer, this does not mean that AI is going to replace all the software developers. But it is rather than replacing the programmer developer, AI will become a great tools for the all software developer to gain new knowledge, to write a better code, what we write a code right now. So, and also AI will be also able to use to archive data, process it, and bring a meaning into that. So in this ways, developer and AI will have a good relationship. Third is error management will become automated with AI. As we know that a software developer, when they test the software, it takes a lot of times and cost money, and that is the biggest things. But in the upcoming days, AI software error can find it automatically and detect the error and repair it without the need of developer. But at the same time, if AI cannot find error or a problem, then human like us, we have to dig out and find the error and correct it. So this is also a very good. Fourth is AI provide accurate software developers. Once again, when I say AI is going to provide an accurate software developer, this doesn't mean that it's going to replace the all human. But instead of, what is going to happen, the AI is going to investigate. The AI is going to dig out a data and past history from the back what they have done, and they will investigate the level of challenges and the amount of time and the money is going to be cost. After that, this investigation, AI will let the concerned person or the developer, this is going to happen, this much money is going to be cost, this much time is going to be consumed, and also AI will let the developer know that if it is worth of trying to correct the software or not. Then it will be depends upon the software developer or concerned person whether they have to correct or not. Fifth is AI will change the way define a leaders. As we know, the AI is growing rapidly. It's not only growing, but it is giving accurate information and better understanding. AI will be helpful for the leader to become decision-making leaders. And also through the help of AI, leaders will not be dependent upon their own limited knowledge, but they will be thinking about critical things, as well as also they will be not depending on a time to spend much time spending time in simple problem, but they will be, as I told you earlier, they will be spending their time to solve a critical problem, algorithm, and such a kind of things. Not only that, the leader will be able to determine the missing information which they have missed out already. And the leaders will be, so the role of leadership will be shifting from strategic making to the mentoring. Leaders will be only mentoring, but decisions AI will be making. At the last, what to expect with the future of AI technology more than just a robot? When we when we ask a common person, those who don't have knowledge about technology or something that they will, if we ask them, what do you mean by artificial intelligence? People will think just a robot. But AI is more than a robot. For example, just we know that the self-driving car, we have never thought about that one day self-driving car is going to come into reality. As you know that already the US Department of Transportation has already passed the will to make a 3-level of car. They are doing some investigation. And other things, so many other things, just like face recognition, your face will become ID, as you know that, and other things, so many things are there, just like a kind of AI will be serving to all small children and elders. Elder don't have to go in nursing home. AI will provide all the facilities and care the children. So such kind of things AI is going to do. It is more than a robot. So thank you so much. If you have any question to ask.
Any questions? The company Aurora WDC out in Madison that we had do the tech talk, they work with AI for making business decisions. So I think this was pretty interesting to see how AI plugs into different industries, including for this week, software engineering for automated testing and other things. So not really a question, I just thought it was an interesting topic.
Yes.
All right, any other questions, comments, concerns? Going once, going twice.
Thank you.
All right, who's going next?
Sure, Ishtiyaq, Muhammad Ishtiyaq.
Okay, go ahead.
I was doing a presentation today. I said, any questions, concerns, almost came out bribes.
Yeah, bribes. Comments, concerns, bribes.
Oh my God, we had like 50 people in the meeting.
It was a reflex.
Oh my God.
Like that Big Bang Theory episode where Amy is trying to get into tell Sheldon that or kind of train him that it's okay if things don't end. Remember that episode? Like she would play songs or that would just abruptly end and stuff like that. That's the same way with questions, concerns. It's just if you got this weird feeling in the pit of your stomach, or you're like,
something's
this
missing.
just isn't right. This isn't right. Okay, sorry. Just had to say that.
Whenever you're ready.
So I choose this topic, Selenium software testing, which is a kind of extension to what Josh said about the automation tools. So basically, back in the day in India, I used to work in Unity, and the Ghalib and also Josh explained some word for the unit testing. So it's a sample code here, and we gonna write the assertions for the test, and also some kind of this kind of sample code where we use for test-driven development, which is a kind of for defining that test, and we have to write test cases within our development process. So, and Unity has its own Unity test runner here, which is built in the upcoming after Unity 5. So here we can see all the green symbols, which are are used for passing the test. I mean, the test for all alike are successful. And here is the test case for defining it with a number of sequences here. So this is a test-driven development, which is used for the unit testing. So it comes under like a functional testing, which kind of development process goes on. But here comes to like Selenium, which is an automated testing tool. And we know that software testing is a basic and important part for the software development process. Without testing, we can't assure the product after the deployment process takes place. So basically, what is testing? First of all, testing is which we can is a type of evaluating a system module by providing defined inputs and waiting for the expected outputs, and then cross checks with our the actual outputs and our desired outputs. So Selenium is a automated software which supports many of the browsers like Safari, Microsoft Edge, Opera, and it is an automated browser plugin that actually inspect all of the elements by itself. And it's just not a single tool, but a suits of softwares that I will be presenting in the next upcoming slides. Before that, we have to get into a look where why it is a major concern about the manual testing and automation testing. Because like in manual testing, there are first of all, like there are requirements for the software testing where everything cannot be automated. Maybe the future is like an AI process where everything's going to be automated, but now at present it's like everything in the software development process is not uh, going through automation process. We have first the testers need to think about which test gonna take manual testing and which gonna test we have an option to go in automation. So considering the whole terms, I have choose this like for instance as a factors, and the more beneficial is one is the automated testing, in which it as well as time saving, and it produces less errors, and we can find accuracy in that. And also the third factor that many companies going through now, like IBM is a best example for the robot of AI in software testing. So like it requires just an initial setup and all the things are gone through well by it, so that it doesn't concern regarding the human errors after that. So writing the test scripts in initial setup, that maybe costs more for the developers side or for the test scripter sides. But after that, everything in the test will be easy in automation. So I just said it's not just a tool, but a suite of softwares. Like Selenium is a suite where it has 4 major components, where IDE and RC WebDriver and Selenium Grid. So basically, Selenium IDE is an integrated development environment for building Selenium test cases. So I have set it in an automated browser plugin that allows the tester to record their actions as they follow their workflow, and all the tests they need to do, and all the things are like recording in the IDE. And now Selenium 3 and also Selenium 4 is in beta version. So Selenium 1 is actually the Selenium Rc and Selenium WebDriver, and two of them are merged into Selenium 2. And now Selenium 3, and which is we are using, many of companies are using it. So Selenium Rc is like a remote control within a client server architecture that receives the Selenium commands that are and the tests that are carried out via browser. So it makes use more of the kind of coding, all of the programming languages, like it supports Java, it supports C, PHP, and many kind of other languages like Python, Ruby, and Perl. and Java, etc. So, and also it contains the automation frameworks, the WebDriver, in which we retrieve our results. So WebDriver here is a main kind of everything that gives our results after testing. We are getting through WebDriver. So basically we are adding the, like here, I'm going to present an example for testing process for validation case. So just we enter password and login. So here what will be the driver doing is taking an Selenium WebDriver and merging into the Selenium Rc and then presenting our test results. So the other component that is Selenium Grid is basically the tool to run parallel testing on totally different machines with equal time. So which kind of, it decreases the execution time, which all of the testing is improved. So basically there are two types of automation, two types of testing tools. One is the open source testing tool, and the other one is the commercial testing tool, which all of the business companies use nowadays. But like open source software testing tool, which is very easier, and automation process goes through well in it. Selenium comes under it. So I will explain an example where a user wants to enter a username and password, and he clicks the login. So here is our test case, and we gonna provide an automation process for it, like installing in Selenium and all of the libraries that are needed for it. And here is the test scripts, and I will show you in the sample code here. So after like testing process, we have to identify first what's the test case is, and defining it into the Selenium or the IDE process, writing a test case, and then it generally automates all of the username and password, and it gives you the result of whether the test is successful or whether the test is failure. And and after that we can do our development process for and we can find the human errors, or it will provide the errors so that we can improve our software quality. So Selenium testing process is very much easy than the other, as it is very open source also, and many of them are using it nowadays. So first is an STLC process where software testing done with the usual planning, and I have shown you what's our test case is here. So it is a planning process, and then coming to generating the basic scripts, and for what test cases we need kind of libraries, and we need kind of scripts for the developer, for the testers, and enhancing the test cases. If you want to attain more and more test cases, so we can add and we can reuse them. So it's a basic advantage point here. And also and then after doing finally run the test and analyze the test results. If the test is successful, it's okay. And if the test is not, and it reports any defects, so you have to take care of the development process. So I will show you some of the sample code here, which kind of use automation framework as JUnit. And I've showed you in the in Unity, he uses NUnit framework, which is a kind of for use for the C# language. And coming to Java, so here's Java code. So they use JUnit framework unit. So we can see in the line here, we are adding a Selenium libraries, and we're also adding a WebDriver, and also it automates with the, he's using the Chrome browser here. So he will be providing the Chrome driver here. And after that, he will providing the path point and a new WebDriver. And then for the automation process here, I said username and password, and the button should be clicked. So here's the test case where we need to find an element by ID, which is kind of like we are providing a test case. We are providing a testing ID, and we'll also be providing a password, and then the click button. So after that, it will automatically close, and then the test will be successful or the test will be failure. It will provide it in a very short and very minute of seconds, we can say. So here's a little video of it.
Right, we wanted to display test failure, right? So we have successfully built a test case. So let me go ahead and execute it. So my browser opened automatically. It also navigated to Gmail, entered my ID and closed the window. But it happened really fast, so you people must not have seen everything. But it says test successful, which means our titles also match. But I would still like to slow the automation down so that you people can actually see everything that happened. So that is also possible. We can do it by thread.sleep. Let's say I'll ask it to sleep for 2000 milliseconds. Similarly, I'll have one more sleep command after we've clicked on the next button. So this is not necessary. I mean, normally testing would require you to do it really fast so that in a matter of second, maybe 1,000 cases can be done or more. But I'm doing this so that you people can see everything that happened. Okay, thread requires us to throw an exception, so we did that. Let me now go ahead and run it. Okay, so my browser is open and I have Gmail and my ID typed in with the screen got maximized, the window, and that's it. We also closed the browser and it says test was successful.
So here is the basic test case where we provided for the test successful process, and he used the Eclipse IDE here. And also we can use Selenium Ide for that. And he provided these libraries here, and find an element with the automated process. We can say that everything is going to be automated. The typing ID will be automated, the password, and the whole process will be automated in just a few seconds. So it's very much beneficial when it comes to software testing to use all kinds of automation tools that are like Microsoft Azure is one of the example, and Docker is one of the example, and DevOps is also an example of where and the Selenium, and also all kinds of Windrunner commercial testing tools like QTP and QA test software that are available in the market. So everything is going to be a software testing process will make us easier, that comes under automation. And Josh explains that in a brief way that the future of the software testing will becomes like the AI process, where everything's going to be in just a few seconds, and we does not need any type of developers, and they just need to do initial setup for all of the things, and that's the case, and this is what it is. So thank you guys.
All right, any questions?
Nope.
I used Selenium automation stuff for some of the travel hacking things. For those of you who had the 518 class last year, I had written an app that went through Southwest's website. I'd use Selenium for clicking on those links to automate. So it wasn't so much automation testing, just automation in the browser, and it worked really well with Python for processing through their website as if it was a human being going through there with like pauses and stuff like that, so that the JavaScript had enough time to load and all that jazz. So it's a pretty cool tool that can be applied to a lot of different things.
Yes, sir. Like it produces it provides more of the multi-platform like Java, C#, Python, any kind of programming languages. And many of the programming languages in Selenium 4 is we doesn't know some type of programming languages that will be supported in future as well. So basic tool and very much good to go for automation process.
Mm-hmm. All right, any other questions? Okay, who is going to go next? I think we have Eric or Seth Blade is going in a couple of weeks. He's been inundated with the 3D printing of the COVID-19 masks, so he gets a pass. So I guess, Debbie has to go too, right?
Yeah.
All right, so you three fight over it. Whoever's gonna go.
I'll go ahead and go.
I'll be back in 2 minutes.
Should I wait until you're back in 2?
Yeah, you should wait until I'm back to start.
Or should I present and tell you it was amazing?
I guess it's up to you. All right, I'll be right back.
All right.
By the way, what's your topic now?
My topic is going to be on version control, Git specifically. It's going to be on Git.
Okay.
I was thinking about the same thing. Because I think nowadays software engineering cannot live away from version control, no matter what you are doing.
Well, save your thoughts until we're all done. So we'll see how I do.
And one of the interesting thing is I'm using Fusion 360, and that is like a 3D modeling application. And since it's you can think it's like RTCAD, but actually it also has version control.
What is that application?
It's a design tool. It's not a coding tool.
Yeah, I know. I mean, what's the name of the design tool, 3D modeling?
I said Fusion 360.
Okay.
It's from Autodesk company.
Yeah,
That was
got it.
really got me interested. Oh, even design tools need the version control. And it documents whatever thing you've done, just as if you think about you are doing Photoshop. It kept tracking everything you modified the picture.
Everyone surviving so far? The coronavirus?
Yes.
The isolation? The
Maybe you will
misery?
see a white cross next time on the Zoom.
I'm struggling to cook here.
You're struggling to cook.
It's a white. Next time someone's still in here, but it's a white cross on the name.
Devi Prasad, can you do
I gotta find this
cooking?
thing.
I've had a cold for like
What?
Oh no.
Yeah, it's been a cough, but like it's not a dry cough, but it won't go away.
Has everyone seen this thing? This is very interesting. I suppose it's very sobering more than anything. It's only for the US, but they break out state by states. These are the models that they're working off of and the assumptions.
I just saw the Wisconsin one. I haven't seen any other ones.
Yeah, it seems like in the Midwest that we're at. I mean, it's going to be bad, but it's not as bad as, say, a place like New York.
Can you share the screen?
Am I sharing the screen? I thought it was. Oh, you know what? I forgot to share.
They're talking about it, so I guess that you can share.
I'm going to get bad marks for this presentation, I think. All right, so this is the COVID-19. This is from the University of Washington. Apparently, they have an institute there that does health modeling, and they do it, I think, for most countries of the world. And they try to say, well, if you were in China, this would be the most troubling health concern. If you're in Brazil, this would be the most troubling health concern. If you're in the Indian subcontinent or Pakistan, here's what's the most troubling thing. But anyways, since we're all talking about COVID-19, they've been modeling. And so what they do is they model how many hospital beds they think that we're going to need. And then I think they'll say how many ICU beds we need. And if you drill into a state, let's look at Wisconsin, for instance. They say that our peak time when the hospitals are going to be most busy is right at the end of April.
Yeah. Okay, because when you guys were saying like a couple weeks earlier, like a couple hours ago, I was like, that's mid-April. And like last I saw, it had just moved from like
Yeah, it did.
to like end of April. So yeah, they're for Wisconsin. They're saying that there's probably, I mean, I don't know what that's saying, but there's probably going to be at least 1,200 deaths.
And
yeah, and probably 80,000 total
Can I
cases.
ask you what is the shadow area?
The shadow is the min and max of their model. So, no model is perfect. So this is the margin of error.
Makes sense.
So
share this link with us, please?
Sure. I will share it right now. In Zoom. I'll even put it in Zoom. Let me find Zoom chat. Zoom on? Oh yeah, here you are. Let's see, chat, more chats. Okay, so if you can open up your chat client.
Well, Littman, you missed his presentation. I think it was awesome.
Yeah, you think it was decent?
Yeah, look what I made.
You
pretty cool. Pretty cool.
You missed it. Sorry.
Yeah, that's right.
All right, so I'm back.
Okay, I'll stop this. But yeah, so if you look at someplace like New York, for example, now the thing that Alexis, you just noticed, it is a moving target. Now their peak is going to be in a couple of days, according to this model. And this line down here is how many ICU beds they have in the state of New York, and this is how many the model suggests they'll need. Margin of error on the low end and the high end. So obviously you can see this is really bad news.
It's like exploding.
Yeah, it really is. And then you can see here, this is deaths per day. And today was yesterday was a sad day with 400. And so anyways, so Blade and Dr. Littman, we're proud of the work that you're doing. We hope you guys keep it up and that people find a use for your masks. But that's not what I'm here to talk about. So let me turn on my timer. And I will bring up Git. Okay, the clock is running. So I was going to talk about version control. That's, to me, an important aspect of software engineering. I don't know if you younger folks, because I'm an older guy, I don't know if you younger folks have had the experience of working on ugly spaghetti code that you inherit from an older developer yet. In my... Yes, okay. My career in software development anyways has only been about 7 or 8 years old. And I have done a lot of editing in projects where people, when they want to do something new, they'd make a copy of a code file and then just start going to town on it. And then they leave it for you and they leave their comments in the code, even like functions and procedures, like massive amounts of comments. So when you start to look at it, it's really hard to know what's going on. Well, that can all be solved if we use version control software. And I'm going to focus on Git because Git is extraordinarily popular. A lot of you have backgrounds in software engineering of one kind or another. Has everyone used Git before? If you know how to raise your hand in Zoom, raise your hand in Zoom. I'm actually kind of curious how many people have experience with Git. I'm assuming it's quite a few of us. Well, anyways, Git was developed by Linus Torvalds. He's Finnish, so that's my best attempt at his name. And if you know anything about Linus Torvalds, he's very famous for two things. And the first thing that he is famous for is that he came up with Linux. He is the guy who invented Linux. And then, not to outdo himself, he invented Git. Linux, I believe he developed in the 80s, and Git was developed in 2005. Git's extremely popular. If you host code anywhere on the internet, GitLab, Gitbucket, GitHub, Git is the preferred version control system of choice used by most of these companies. And interesting thing about Git, I never knew why it was named Git. Git is a British English slang word that's not very nice. Apparently, Linus is a not nice person. He's kind of a jerk. He's also in charge of the Linux development tree. So he developed Git so that people could use it to collaborate on the Linux kernel. And he actually has the final say on what goes into the Linux kernel, even still after all these years. And I guess he's very abrasive and mean. I guess if you invent Linux, you get to do that. So Git is an unpleasant, silly, incompetent, annoying, senile, elderly, or childish person. So anyways, I never knew that. There are many different version control systems like Subversion, Mercurial, Git. Git and Mercurial are decentralized version control systems, and the way they work, the way Git works in particular, is the project, all of the code is wrapped up in a project called a repository. And the repository is a complete copy of everything that's in the project code, maybe metadata files, the history of all changes that have been made to the file, attribution about who's done it throughout its history. So this is a shot from the Git repository that we use in my department. I guess I was kind of exaggerating just a little bit about us being reactive. We actually do implement good practices, but we don't have an established like Scrum, Agile, or Kanban methodology. We do have a Git repository. What this is showing here is that we don't merge very often because we actually only have one branch. We just all work off our master branch. So it looks like we have many branches. And you can see here, something that a Git repository does is it keeps track of each commit that someone adds. So every time you're working on a code file or something in the repo, you have the opportunity to make changes to it, and then you can commit it back to the repository. And Git actually has a little database that's a part of the repository that keeps track of everything. The way that we do it at Concordia is we have a Git application server where we host a centralized repository, and Git is decentralized, so everyone will take a copy of the repository, a clone of it, and put it on their local machines, do their development there, and then when they need to put the change back into the master repository, they'll push their changes back up. So this is an example of a commit history in one of our files. You can see here this is a PL SQL package, and it's actually bad programming practice if you know anything about PL SQL, but I can see that one of my colleagues was changing an academic term code for a process that he's running. He was switching it from the spring of 2019 to the fall of 2019. If you're a good programmer, you shouldn't put literals into your code, so you have to change it every semester. You should actually come up with another way to do it. However, that's the reactive part of Concordia. We're small enough that that's not a big deal. So what I want to do in the short remaining time that I have is do a little demo of a Git repository that I created on GitHub and look at some of the basic commands and features of Git. So I'm going to do a clone. Like I said, Git is decentralized. Whereas Subversion, if you work with Subversion, you're actually going to have a version control server where you check code out, work on it, and put it back on the server. With Git, you're going to pull the repository down to your development environment. You're going to work on a complete copy of everything that's from the remote repository, and then you can push your changes back. So here's my Git repository. Let's just take a look. It's called RP4. I have 2 code files in here. This is a little program that downloads data and then does a transformation process on the data. And what I'd like to do is I'd like to write the code that does an analysis on the data. So let's just look real quickly at well, first, let's go ahead and add a file to this. So the first thing I'm going to do is I'm going to check the status of this repository. Status comes back, there's nothing here. So I'm going to go ahead and write some code. I'm going to write touch, analyze, and display data.code. I'm just going to go in there. Here is some really great analysis code. Okay, so I've made a file. I've downloaded a project from GitHub. I've added to it. And now what I need to do is I need to let Git know that this exists. So I can see here when I type in Git status that Git knows that I've just created a file, but it's not tracking it. That tracking, I come back here, is what this is all about. This is Git tracking it. So if I want to manage this file, I need to go ahead and add it to my repository. So I've added it, and now I want to make it permanent in the Git repository. I want to say this needs to be a part of my local code base. So I'm going to do a Git commit. Say added analysis logic to program. Save my work. And if I go and take a look now, I can see that I have 3 files. If I go online to my remote repository, by the way, there's another COVID-19 thing that's on Git if you want to look. I can see that I have 2 files right here. One of the neat features of Git is, like I said, it allows for distributed editing, is I can go ahead and push this up to my repository. So I am going to say, take my changes and throw them back out there. Okay, they should be up there now. I will refresh my web page. And there's my analyze and display. Although I've one of the things I wanted to show about Git tonight, one of the cool features is I wanted to show the way that you can use it to find bad code. Let's say that I clone this repository and someone else had been working on it. I add my code and then I do say I put some unit tests on it and they start failing. And I start taking a look at the code, and lo and behold, I look at the code in here and you can see in my transform process, someone introduced a regression bug that broke everything. Well, gee, let's look and see how many commits have been made on this. So I can use a command called git log, and I can see that there have been, how many is that? I don't know, say 8 or so commits to this repository. I need to figure out which one of these commits, which one of these changes to the code broke it. That's going to take some time. So what I'm going to do is Git actually has a tool called bisect that will allow me to analyze the code in my repository, and it's based on binary search. We all know how binary search works. You take a sorted list, you say, I want to find this number, you go in the middle, you say, is the number greater than or less than, and you keep dividing the list in half so you can solve the thing in logarithmic time. Git has a tool called Git bisect that can do the same thing for us. So the first step I'm going to do is I need to track down who and where this bug was introduced, but I don't know. I don't want to go through each of these commits one by one. I want to use the git bisect command, which will take me far less time to find it. So I'm going to say git bisect, and I'm going to say start. And I'm going to say that the part of the git branch that I'm working on right now is bad. So I'm going to say git bisect bad head. I know that where I'm working right now, I have bad code. That's called the head in a git. If you're at the front of your git commit branch, that's called the head. So I know I'm on the head, so I'm going to say, okay, well, the head is bad. Now I need to let it know when was the last time it worked. I'm going to say, well, I know that the last time it worked was probably right here when I created the download script and ETL process logic. So I'm going to say that that commit is good. So I'm going to say that is good. And what you're going to see here is I was on something called master. I was at the very top of my repository. Now it's moved me to a commit that starts with df299. So it's put me right here in the middle of my commits and says, hey, take a look at the files here. So let's take a look at that. I don't see my regression bug in here. So I'm going to say git bisect good. Now it's going to move me to this one that starts with 07D16. So which way is it moving? It's moving me up towards the closer to the start. And since this is small commits, that's probably in there. So now that I'm in this part of my revision history, I'm going to go ahead and take a look at the file that's there. So I'm going to cat. Look at that. That's where the bug was introduced. So I will say git bisect bad. Okay, so did it move me up? It did. It moved me to another one. So I'm going to go ahead and look at my file. And if you were doing this for real, you would actually be running each time that you brought up a new set of code from your different commits, you'd actually be running unit tests on them in some automated way to test your code out to see if the test would show that it was broken. Yep, this one's bad as two. See if Git can do its magic. Oh, at 11 minutes. Okay, and now it's identified for me that this is the first bad commit. I can go up here, see, okay, do a git checkout. I could do a git checkout with that number, which will put me right there. And I'm not going to fix and patch it. But now I can start working, or whoops, excuse me, if I did it properly. I can start working with the code right here, fix it, and then patch it. Anyways, if I'm sure we're all using Git, I'm going to conclude my presentation there because I keep getting dinged for long ones. That is a brief demo of some of the, there's a lot more to Git, but that's some of the cool awesomeness of Git that we can tap as software developers. So there we be.
Yeah, so that last feature is pretty interesting because, you know, in my classes, we've been using Git for, you know, many years, but it's always for convenient ways of sharing code and things like that. That's kind of where GitHub, you know, really shines, is the idea,
yeah.
You know, you can get code out there to different people, but, you know, because we don't have the opportunity to do this kind of in the classroom, but when you get out in the industry, there's plenty of opportunities to do this when you're working on the same code bases with 40, 50, 60 different people, being able to go and find where problems are and get as close to where you are today, where the problem wasn't, and then even being able to merge two different branches together that have, one branch has half the good stuff, the other branch has the other half of the good stuff, and then there's a third branch that's broken. How do you merge it together? And if you get pretty good with Git, you can not necessarily fix all the world's problems, but you can probably save yourself a lot of time rewriting a bunch of code by getting yourself as many good places as possible.
Absolutely, and I chose to actually study Git a little bit more. We use it very basically at Concordia. We don't tap near its potential. We probably use it like a shop that uses Subversion. That might mean something to Dr. Littman, but that's actually why I chose this. I wanted to learn a little bit more because I knew that there are ways for us to be better. And actually, a paradigm that I learned about, I didn't study, but I saw it when I was researching this, is now we have DevOps. Now there's a process called GitOps that's inspired by Git. It's kind of a logical continuation of Git and developer operations, which is really interesting.
All right, any other questions?
So like Badr said, I have to ask you a question regarding, you showed us the commands. Like GitHub also uses visually type, like we can commit easily within a short period and with just a couple of buttons. And you showed the command line codes for all that, the behavior working background.
Yeah. Yeah, and
okay, thanks for it.
Yeah, that's thank you. Is that Ishtiaq?
Yeah.
Okay. Yeah, no, that's just because as I work with Linux a lot, I'm actually more comfortable with the Git command line than with the GUI tools. It's one of those things. If you have experience working in Linux, you'll actually find that it's easier to use a Linux-like command line than it is to use a GUI. They're not hard. There's a bit of a learning curve, but they're not hard once you practice with them.
Oh yeah, I find it very difficult while learning the command line tools. So that's the reason that when I used to work in the development process back in the day in India, so I use Git for just committing changes and merging those in GUI tools rather than going into command line tools. So it's basically very easy. And thanks for providing a basic structure of what is going background.
My pleasure. Thank you.
All right, anything else? All right, so we have Debbie or Eric, right? Fight to the death.
Shall I go?
All right, you're up.
So today my topic is progressive web apps. This might not sound like it's one of the software engineering technologies, but it is related to software development, kind of. So I'm just going to stick with it. So progressive web apps are just like websites that behave more like native mobile apps. So that developers can update them directly on their web server without submitting those updates to several different app stores, and also same app will run on all the platforms. So when you install a progressive web apps, you'll get a home screen, taskbar, or a desktop shortcut that launches the app directly. This app will load quickly and will include offline support as well. This supports push notifications and background sync as well. So basically, progressive web apps are like a website with mobile features which runs on mobile. So today I'm going to cover these topics in progressive web apps, like what are progressive web apps exactly, and why we need to use them, and what are the benefits of them, and how we can build a progressive web apps. What are the rules to build a progressive web app. So progressive web apps, they're also using existing web technologies to access location services, webcam, and other extra features as well, just like the mobile applications and desktop applications. Progressive web apps are traditional web apps, but they give mobile apps like user experience. Unlike mobile native apps, they don't work in all, they work in all other mobile OS, such as previous versions of Androids or iOS as well, because they work on web technologies with mobile features. That's it. So if we consider mobile applications, they need to be updated as per the uh, OS features and protocols, so that they work accordingly and load fastly. But in case of progressive web apps, they can run in any OS, older versions of OS as well, but they might lose some features because of the browsers are not updated in those OS. So why we need to use progressive web apps is because, hello?
You're good.
Yeah, okay. So this is kind of the diagram which shows the combination of website and mobile application features, which together puts into a progressive web app application. So why we need to use the progressive web app applications is because if you consider native app applications, we need to go three kind of major issues. We need to consider these three, like, is this app worth downloading, or do I have enough space on my disk to download the application, or do I have any available data which is sufficient to download the application and to push the updates for those applications. So recent survey shows that this graph, so 63% of the websites use 2G network to access, and 60% users like to have home screen on their mobile, home screen icon as on their mobile phone, and 40% of the application downloads have been increased after using progressive web app applications. So, and also a recent survey shows that not all the mobile applications, native mobile applications, are worth downloading or satisfying. So some people don't even want to install applications on their phone because it's consuming most of the disk space. So because of that reason, they kind of switch to this progressive web app applications. This was proposed by Google in 2015, and as soon as it was proposed, and they got so much of positive response, and so from that time to till now, they've been developing new features and adding new features to the progressive web apps. So most of the apps have fully responsive website performing responsive displays, performing the same functions as so as the progressive web apps supports same features like mobile applications. So all the companies which are having the mobile applications as a primary connection with the customers, now shifting towards the progressive web apps because it consumes more less space and less data as well, because mobile applications it consumes on an average it consumes at least 30 MB to 200 MB, whereas a progressive web apps consumes just from KBs to 30 MB. That's it, because it's a website basically. So, and these are the features of the progressive web app. So these progressive web apps can function offline, and mobile specific navigations, just like the features, extra features which can access the location and cameras, and it also has push notifications. These progressive web apps can also create a home screen icon, and no download is required, no much download is required, just few MBs, that's it. And they can bypass marketplace because the native mobile applications, they need to be uploaded to the Play Store or App Store, but these can be downloaded directly through URL, and this can be linkable and shareable. As this can be downloaded through URL, they can also be shared as a URL to others and suggest them to download it. And it is indexed by Google, and low data is required for downloading and updates. Also, it gets automatically updated in the background. Whereas these features are not available in native app, as you can see here. So these are other examples for the progressive web apps are Twitter, Starbucks, Pinterest, and Forbes. I'm not sure about the offline access, how this works. I need to search more on this because I know there is a JavaScript code for this, but I didn't went too deep in exploring that. So how to build a progressive web apps is first we need to consider whether the website is suitable for to be converted into a progressive web app or not. Because if the website is not responsive, then we can't convert it into a progressive web app. It turns as a failure itself. And also we need to consider its performance and its existing web app analytics. And also the first most thing we need to consider is whether the website is on HTTPS or not, because without HTTPS it's not secure to run the website. So which means we can't run the progressive web app as a secure as well. So if these conditions are satisfied, then we'll start creating the website on the application shell. Application shell is nothing but the code is written within the single page of the main page of the website. And here we'll be using inline CSS because the page should start immediately. And if the inline CSS is not included in this main page, and if we are using another CSS file separately, so what it does is it gives a time gap as a white blank screen while loading the application. That shouldn't happen with the progressive web apps, just like the native mobile applications. So that's the reason the inline CSS is used here. And with the inline CSS, they'll use JavaScript as well. So once the JavaScript is loaded, it directly boosts the React framework. And in another step is register the service worker. Service worker is nothing but it allows the progressive web app or the web application to work offline. So this is the area I didn't cover properly. And another step is we can add push notifications with the using this JavaScript code, and we use this web app manifest, which is basically a support feature to add the application as a home screen icon. And we also use this cache static resources, which also helps the web application to load fastly and read the offline data. And configure the install prompt, which is, let's say, if the user visits the site regularly in a given time span of time from like if you visit the site in 3 days, like in 7 times. So the analytics will collect the data and just prompt it whenever the next time user visits the site to download the application. Such pop-ups are displayed on that. So after this, there are another analytic tools to collect more information from users to improve the application. So this is about progressive application. Thank you. Any questions?
Questions?
I hope I covered it in 10 minutes.
It was a little over, but it was much, much, much better.
Thank you.
Going once, going twice. All right, so then we have Eric. I think it's the last person, right?
Yeah, I think so.
All right.
All right, should be up and running, yeah.
Yep.
All right. Sweet, here we go. All right, software engineers form a critical link between programmers and computer engineers to ensure that system designs and capabilities match what a user needs. A romanticized subgroup of software engineers are a group of people called penetration testers, otherwise known in society by a more cliche term of hackers. Now, this group of people, whether working for good or for ill, need to be experts on how systems work and what software they can build and deploy for their own ends. Usually this comes in the form of malware. Well, let me show you what I mean.
Makes wolves such good predators? They're smart. Rather than hunting strong, healthy prey, they go after the weak, the injured, the sick, the most vulnerable. Todd here happens to be the CISO, or Chief Information Security Officer of one of the medical world's biggest software companies, which means he's in charge of keeping all their data safe should the bad guys come knocking. At the moment, Todd is experiencing some chest pains. Maybe he ate some bad fish, huh? But I know what's really going on here. Tons of hospitals use Todd's company to host all their patient data in the cloud. Now, if I can remove him from the equation, no one here would have the authority to take the company offline and secure all that data during an attack. So last week, I paid his doctor a little visit.
Carmela, the doctor will see you now.
Good luck with that hip, Carmela. At offices like this, people are rarely at their desk for long. Of course, that wouldn't be a big deal if their smartphones could automatically lock down their PCs when they walked away. But right now, I'm hiding some malware that will allow me to bypass all their protections. This old PC, they'll never be able to detect or remove it. This way I can access Todd's file, and thus all his prescriptions. Just like that, I was able to mess with the dosage of his blood pressure medication, the side effects of which are dizziness and really bad indigestion. And now, a trip to the hospital, just like I planned.
Any family members you want to contact?
My wife, but I don't want to worry her. I'm sure it's nothing.
Oh, it's going to be something, all right. Most people think hospitals are scary. They've got no idea. Hospitals just like this one might be home to some of the most advanced medical equipment on Earth. But, like most businesses, they're also crawling with unsecured printers like this guy. Without BIOS-level protection to keep it safe, anyone can install just about anything on here. Now, that little software update just allowed me to create a backdoor directly into their network. I just changed his name in the system. Seriously, this thing is like a sieve.
I can take good care of it, John.
John? His name's Todd. You can't even keep his name straight. Now, if someone, his wife, or say anyone from his security team back at the office calls looking for him in an emergency, no one's going to be able to find him. Sweet smell of success. Get comfortable, Todd. Things are about to get real interesting thanks to that old printer. If it had threat detection, it would have stopped my attack before it started. But since it doesn't, there's nothing to stop me from using it to print out some results I made all by myself.
Here are the revised labs, doctor. Okay, thank you. We are going to have to increase your medication. You're going to feel a little groggy, but it's okay.
Talk about the gift that keeps on giving. Now he's going to sleep through the night. Guess we no longer have to worry about him answering that cell phone over there. You're probably wondering why I go through all this trouble. Well, I'll show you. 3, 2, 1.
This is good.
You're right about that.
Am I the only one seeing this?
Oh, no.
Oh, yes.
We need to call Todd.
They take it upon themselves to cut off every hospital on their network, or hope and pray that Todd will miraculously appear to save the day. He ain't coming.
What am I looking at?
Sir, it appears there's been a data breach.
Yeah, I can see that.
Where the hell is Todd?
At the moment,
We don't know where he is.
you don't know.
Someone is stealing all of our medical records.
From all of our hospitals, and you don't know where the hell Todd is?
I love a good mystery. Don't you? I'm sorry, Dave. It's not personal. With their chief information security officer out of the picture, they're basically paralyzed. Even though they spend a ton making their network super secure, it turns out the PCs attached to it were not. Does this thing have hardened multi-factor authentication? Nope.
Even the backup servers have been compromised.
Hardware enforced protection to stop these poor folks from exposing everyone every time they clicked on a bad link? Negative. Without anything like that to stop me, my malware can devour every file it touches. Time to dial up the fun. I now have in my possession the health records of millions of patients. All because I hacked one doctor's office, one hospital, and made one guy disappear. Let's put Todd back on the grid, shall we? Oh, come on. You didn't really think I was just going to leave him here, did you?
Sir? Your wife is on the phone.
Yeah, Todd's okay.
Hey, honey.
Though I can't say the same for his company. But for me, this is a whole lot bigger than them. This is about getting the world to see all the holes in the system. So we can tear it down, piece by piece. Weakness by weakness. So we can rebuild it. And to those of you in the hallowed seats of power and government, know this. You're next.
So while it was kind of a clever advertisement, I think it goes to illustrate the very real threat that malware poses, and especially in how it can bring together and break apart groups of engineers. Malware itself is broken up into various different categories, and there are 9 of them that most of the research that I found really focused on. Specifically, adware, which is focused on throwing advertisements, usually while you use a web browser. Spyware, which sits in the background and observes everything that you do on your computer. Viruses, which modify programs on your computer. Worms, which are kind of like viruses, although usually they're more targeted by spreading from system to system and destroying data and files as they go along. Trojans, which are really nasty little bits of code that can sit there and pretend to be legitimate code, but then install viruses or other malware behind the scenes. Ransomware, which has hit the news from time to time, locking people out of their files, encrypting their hard drives so they can't get to their computer systems. Rootkits that give hackers administrative privileges over an infected system. Keyloggers that just simply record your keystrokes. Exploits, which are bugs that can be used to achieve various malicious ends. The thing that really hit home for me, though, when I started to take a look at how to prevent these things, is that there really are 5 primary ways that you can protect yourself from malware. Now, the first, obviously, is to have good anti-malware and antivirus systems that are constantly updated and run frequently. The interesting thing I found was the next 4 really fall in the category of being vigilant and intelligent about what you're doing on the internet. Things like not opening email attachments that don't appear safe or from people you don't know. Not going to websites that are not safe, especially sites that promise assistance with doing things that are illegal or immoral. And those 2 things alone account for almost all of the malware infections that we see today. Other safety things, obviously, are to know the software that you're installing, which is really cool in today's world, as most software providers have what we call checksums that can be used to verify if a software has been tampered with or not. And finally, pay attention to what it is that you're installing. I know I can get lazy at times and just simply clicking through the prompt, but if you're not paying attention, you could be installing things that you don't want. I run IT for a lot of different things here at Lutheran High, and I can't tell you how many times over the last 6 years I'll get complaints about the slow internet, only to look at their computer and find a ridiculous amount of toolbars, almost in many ways similar to the picture that I have there. And people are wondering why it is that their internet is moving so slow. So keeping an eye on all of these things is really, really important. But you don't have to take my word for it, because Mr. Gonzalez also approves this message. Questions, comments, bribes, the like?
Brilliant, brilliant.
I really liked the video. It was really, it really draws you in.
Yeah, and that was
it's still.
That was a cool thing that HP actually put out a couple of years ago. They did a 3-part series that you can find them on YouTube. They've taken them off their website for some reason. I don't know what the deal is with that, but yeah, it's really interesting because in the first one, he hacks a printer system and ends up making his way all the way to the corporate offices where he ends up disrupting a deal. And in the last one they did was actually a 20-minute video that went through everything from CCTVs to printers to computers that weren't updated. So it's an interesting thing.
Got good information for me to get 9 kind of malware, what are the things are there, so you explain one by one. It's good.
Yeah.
Some of them I don't know before, yeah.
Yeah, that video was really cool.
Yeah, it gives you a lot of messages and very much less time. It gives a lot of information. It's good.
Yeah, I'll see if I can find those YouTube links and throw them out in Slack maybe if you guys are bored while we're all sequestered.
Yes.
Especially nowadays, due to the coronavirus, people are not going anywhere. At least they can watch.
Eric, so are you a night person? You seem to go last just about every week.
I don't really care. It's always interesting seeing what everybody else does too, because I was watching everybody's presentation. I was like, wow, I could have gone completely different ways with my even with that same video. The whole software engineering process that most of the early presentations talked about, how is it that it can adapt when it comes under fire by someone who doesn't want to play by those rules?
Yeah, I was thinking the same thing. Watching other people's presentations, just the different things I didn't think about.
So I would say to Eric, the last, the best.
So he basically just said everybody else was crap.
Yeah, that's.
I just want to make sure I'm like translating this.
It was just because I had Mr. Gonzalez in it, so I
was gonna say we can't fight with Mr. Gonzalez. That was such a brilliant move, Eric. Amazing.
Hey, I started with my Judas doll, so.
That's like his nemesis, though.
No, they're friends.
Yeah, well, I'll tell you what. When I took my break and I went up there, Mr. Gonzalez was giving Ollie a bath in the kitchen, and everybody knows who Ollie is, right?
Yeah.
Oh, who Ollie?
Pet honey badger. This is Ollie. And there really is an Ollie. He's had him for years. So he was giving him a bath, and Ollie is absolutely vicious. Nobody keeps a honey badger as a pet, but Mr. Gonzalez does. So it was pretty violent.
So when we are having the tech talks again?
Isn't it? I think it's the 6th.
It should be next Tuesday, I think it is.
Yeah, I think so.
Tuesday.
7th. Oh, I'm in the wrong. Where am I? What is that? Yes, the 7th, Tuesday, 6 p.m. And it'll be in this room. I'll send out notification, but it'll be 6 p.m. the normal time, but we'll be in the it'll be in the Zoom classroom, not in actually on campus, obviously.
Okay.
All right, so then next Thursday we do not meet because we're on Easter break. Although I'm going to try to set up some sort of, I don't know, Easter pizza party Zoom thingy or something. We're going to have some sort of like festivity thing, maybe not on Easter Day.
Are you gonna have pizza delivered to everybody's house?
I was thinking that.
I was thinking the same thing. I need food.
Including Michigan.
People have to sign
We can providing our address.
Yeah, that would actually be a cool thing. And just do like a movie night or something like that, and watch pizza or eat pizza and watch movies.
Wait, so you said you are going to deliver us pizza?
There's a possibility I could be talked into that.
At least a slice, right?
Let us know how your princess stocks are doing.
Well, I took some out the other day. I had a bit of a down day today.
Yeah, so if it's a good day, then we all get pizza.
What is the material used for the printers and the masks?
What's this?
What's the material used for printing those masks?
Oh, it's PLA plastic.
Plastic, yeah.
Okay.
Through the 3D printer, right?
Yep. So Blade has given up eating and sleeping.
Indeed. Yesterday, I only had an apple until 4 p.m.
Oh boy.
How many masks you have made it?
We made at least 300 already.
Oh.
Yeah, we have a whole bunch of different models, so
yeah, different models.
Printed a whole bunch more than that. We just have different models of things that we keep going through.
Bravo, Blade.
Nice job, guys.
Great.
All right, well, so I will see everybody well, I'm around, so if you want to get on Zoom or come to one of our happy hour hangouts, do so. Otherwise, next class is 2 weeks from today, right?
But we'll see you for the tech talk.
Yeah, you'll see me for the tech talk. That's correct. Next Tuesday.
But next presentation, it's going to be on the 16th? Or?
Let me confirm.
16th is
embedded.
Yep.
Embedded System Lab Day. So 23rd?
Yeah. I mean, if you look at the calendar on Blackboard, it shows you kind of when things are.
Okay.
But here, let me just bring it up so I can mentally confirm.
Topic is blockchain, right?
Yeah.
Jamila looks so tired and sleepy.
Yeah, 23rd is the next presentation, but the next time we meet is on the 16th. And we'll do embedded systems, and those are due on the 23rd. Okay?
23rd, both embedded system and due and presentation also. Right?
Correct.
Okay,
And just like this week, your embedded systems were due today, even though most of you turned them in last week.
Okay.
So we will not meet next week, although I'll be around. So if anybody wants to watch movies or something, let me know. Otherwise, we'll meet at our normal time on the 16th. All right. Stay safe.
Good night.
Peace.
Bye.
Good night.
Take care.
Bye.